Καλησπέρα.
Καλησπέρα.
Welcome, everybody. We're going to begin shortly. Thank you for waiting.
Hi, everyone. Sorry for the delay.
Hi, everyone. Welcome. I will first arrange my speakers. There you go. So welcome, everyone. Welcome to Women Plus, to our to day 3 of Women Plus, our symposium celebrating Greek women in STEM. And welcome to our session on engineering, environment, and the energy transition. I am Natasa Papangelou. I am an environmental engineer and postdoctoral researcher at INRA in France, and one of your co-hosts for today.
Hi, I am Dr. Kousi. I am a lecturer in chemical engineering in the University of Surrey in the UK. And welcome from me as well. So I know we named this session like engineering, and when you think about engineering, there are a lot of different things that you can think about. It can be like bioengineering, working on artificial limbs, for example, it can be civil engineering, working in housing. It can also be computer engineering or electrical engineering, working in computer microchips. But as Natasa said, today, we're going to focus on how we engineers, I say we, we're not all engineers here, but we work on the environmental engineering aspect of things.
So we wanted for this session to bring on all these different aspects, but focus on a specific and timely and important aspect. And this aspect is, as you may know, our planet is not doing very well. There is this species called humans messing up a bit of everything, roasting it up, chopping it up, and all these things. So what we wanted to do today is to gather these speakers and discuss some solutions, discuss some issues, discuss ways from engineering or not that we can maybe use to address some of these issues. And for this reason, we have invited a group of some great scientists working at the forefront of the research on environment engineering and the energy transition.
Before I introduce our first speaker, I'd like to say that myself and Natasa, we don't want to interrupt you if you're a bit late with your talks. So what I'm going to do is 2 minutes before starting, I'm going to open the microphone and we'll do this. So
careful.
Just keep that in mind. So our first speaker is Professor Hrissi Karapanagioti. So Hrissi is an environmental engineer and an associate professor at the University of Patras in the Department of Chemistry. And she works on environmental chemistry with emphasis on liquid pollution. She has been working with microplastic research since 2004. She has edited 2 science books for Springer, and she has a huge experience in translating, let's say, science to the public. But what I want to say about Hrissi is she was my professor when I was in the chemistry department in Patras. And I think it's quite important to mention that she came when I was about, I think, 3rd year or something. We're all so excited because there's a new professor in town, and she's young and she's a woman also. And we all wanted to see, you know, what she's going to do with it, because we all know there are not that many women professors. And sure enough, she is actually very inspiring. And I had her as my professor during my master's degrees as well. And I was doing a master on anti-pollution and catalysis. And Hrissi used to drive us with her car to different industries so that we can actually take a closer peek into what this is and not just read by the book. So enjoy her talk. It's on microplastics. And again, Hrissi, thank you so much for being here with us.
Thank you. It's a pleasure. Good afternoon from me, and Kalispera. It's also a pleasure for me to see my students, you know, go that high. So I'm really happy to be here today. My talk is about, can I share the screen? Yes. Okay. So my talk is about, the title of my talk is Microplastics. And as I was writing this, it came to my mind this scene from a 1967 movie with Dustin Hoffman that talks about plastics. And I hope I don't sound like this gentleman in the movie that talks about plastics. So let me.
I just want to say one word to you. Just one word.
Yes, sir.
Are you listening?
Yes, I am.
Plastics.
Exactly how do you mean?
There's a great future in plastics. Think about it. Will you think about it?
Yes, I will.
Enough said. That's a deal.
So I hope I don't sound like that when I say microplastics, but it seems there is a lot of research to be done on this topic. So microplastics is pieces of plastics that we can find in the environment that are lower than 5 millimeters in all their dimensions. And where do they come from? Actually, when the movie that I just saw took place, it was about the era where plastic stopped to be such a wonderful material and shiny, colorful, and so on, and became something really cheap that anybody can buy. And it entered our daily lives in huge, huge amounts, and especially with the worst form of material, single use. So because we are using a lot of plastics, and especially single-use plastics in our everyday life, the environment is full of this material, and this material, we think it stays in the environment for many hundreds of years, and it's true, but it doesn't stay in its initial form. Many of these plastic items break down into smaller pieces, and they are much easier, you know, to be distributed throughout the environment, to diffuse everywhere. So when I started in 2004, as Kelly mentioned, studying microplastics, I was one of the first, let's say, 10 scientists in the world that we were studying microplastics. And we thought that microplastics were these small blue, yellow, red pieces, but When the analytical chemistry started studying microplastics, we found out that we even have nanoplastics, plastics that we cannot see with our naked eyes. Even the pictures that I have here, they are from microplastics, not nanoplastics, because it's really difficult to capture nanoplastics and to monitor for nanoplastics. And not many people right now can do that. But the problem is that these nanoplastics are the most dangerous ones because they can enter our body and they can actually enter our cells. They can penetrate the membrane of our cells. So they are really dangerous. So how it all started, I'm gonna just share my story about my plastic story, let's say. How it all started. Okay, so when I was young, not in the picture, but when I was young and was going on vacation with my parents, I used to notice these tiny plastic pellets. They were round and off-white in color. And I thought they were fish eyes. So I collected them to make a necklace and things like that. Later on, when I went to do my PhD in the United States and then return back to Patras in Chemical Engineering Institute, and at that time we used the library a lot, and I saw in the library this cover page from Environmental Science and Technology Journal, and I recognized this material that I used to collect when I was young. And it was really curious what they are and how come they are in the cover of this journal. So it's a plastic pellet and it says transport of toxics in ocean environments. So this is how come I started wondering about me being a child and collecting this material that transports toxics. That was really a shock, let's say, because I still have like a matchbox full of these plastics. And I started following publications from this group, this Japanese group that published that cover page article. And I saw that they have noticed that depending on the material of these plastic pellets, if they are polyethylene or polypropylene, the amount of toxics that they carry with them is different. And they were wondering why. And during my PhD, I had recognized that when organic pollutants are in contact with solids that have different properties, they demonstrate different affinity for them. So the absorption of organic materials is really depends on the material of the sorbent. So what I did, I thought that, yes, I have the knowledge based on my PhD to answer their question, why polyethylene would have much more organic pollutants on it than polypropylene. And also during my, let's say, when I was teaching in the University of the Aegean, I had a collaboration with Stanford University where they wanted to study how the pollutants are transferred within the plastic pellets. And they use a unique instrument called the laser desorption laser ionization mass spectrometry, where they can actually measure the organic pollutant, polycyclic aromatic hydrocarbons on plastic surface. So that was a unique instrument that exists only in Stanford and in Zurich, I think. So this is a study that took a lot of publicity, let's say, because of this, of the uniqueness of the method, of the analytical method. So based on these two experiences, I started studying absorption in the laboratory. and try to explain the results that the Japanese group have found in the field. So I joined the research, and they invited me to join the research, and we have published several papers related to the pollutants that can be found on the surface of the, or inside the plastic pellets. And we saw that in Greece, even though it's a very small country and the sea is very close, we saw that in the Saronikos Gulf, the concentration of the pollutants on the inside the plastic, it's much, much higher than the pollutants we can find on inside the plastic in other areas that are not polluted. So we use the plastic pellets as a pre-concentration factor to pre-concentrate organic pollutants that can be found in the environment and be able to measure them in an easy way. That was our initial goal, but as we continue to study this topic, we were approached by IMO, the International Maritime Organization, and another, let's say, agency that belongs to IMO. It's called Gesamt. And those people were studying microplastics in the environment. So they invited us in UNESCO in Paris, and they asked us to focus our research mostly on the microplastics and the pollution in the environment. So we continue. Okay, we continue this research with other research groups. I met, for example, Barcelos group. It's a big analytical laboratory in Barcelona, in Spain. And they did the analysis for me for perfluorinated compounds. And we found some, relation between the pollutants we found in the sea and the land uses throughout Greece. And of course, we started also in my laboratory to do the analysis and take part in interlaboratory exercises and so on. And this collaboration resulted in a Nature paper in 2013 and a Springer book in 2018. And there we talk about...
Sorry, it's about 2 minutes left.
Really? Okay. Okay, so I will continue. So, but just to say that we have proposed to classify plastic waste as hazardous. So I'm going to go very quickly just to show you. So my research went on to study wastewater treatment plants and how microplastics pass through them, and then plastic bottles and plastic bags. And we use also techniques that were found in the University of Patras to study the surface properties of plastics and how they degrade in the environment. And our last study is on greenhouse plastics, and we talk about plastics that we can find in cultivated areas. And as Kelly mentioned, we have done a lot of work with education and tried to translate our science into studies. And I have published recently a book in Greek about the general public. And just to finish my talk with this picture from Jennifer McClatchy that shows that, plastic is not that cheap, and it's not going to be that cheap forever. And if everybody, take our responsibility and bring the plastic that we waste into our house or into the landfill, it won't be in the environment. So everybody can do something about it. Thank you.
Thank you
And
so much.
sorry.
I tried the whip, but I understand that it didn't work.
Thank you.
Sorry, I'm going to interrupt you if I need to, sorry. So normally our next speaker would be Pavlina Nanou. Pavlina is leading scientist in the TNO organization in the Netherlands, and she is also the founder and CTO of a new startup called Turbines. Unfortunately, Pavlina's father passed away, so she couldn't be here with us today. So we're going to move on to the next speaker. It's Dr. Fenia Sapountzi. Welcome, Fenia. Fenia is a senior scientist working in Syngas Chem in the Netherlands, and she also works for DIFR, which stands for the Dutch Institute for Fundamental Energy Research. Fenia works in a field that's very close to my heart and my interest, and this is on the electrochemistry and its role in the energy transition. Today, she's going to talk to us about electrolyzers and their input in all of this. Please, Fenia, take the floor.
Thank you for the introduction, Kelly. Yeah, give me a minute to share my screen. Okay, so Kelly, just to confirm, you can see my screen now, eh? Okay, nice, thank you. So good afternoon, everybody. Yeah, my name is Fenia Sapountzi, and as already mentioned, I live in Netherlands since 2015, and I work here. And I have obtained my bachelor, master, and PhD from the University of Patras in Greece. I obtained my PhD under the supervision of Professor Vegenas. And before coming to Netherlands, I worked also in Spain and in France. So in the first part of my talk today, I will explain to you briefly the challenge of the research field that I and Kelly actually work. So why do we do this kind of research? So the human activities related to energy, agriculture, transport, industry, and together with the deforestation, cause the release of greenhouse gases to the atmosphere. And among these greenhouse gases, carbon dioxide is the major contributor. And as you can see in this figure, the atmospheric concentration of carbon dioxide is continuously increasing. So the question is first, where these carbon dioxide emissions come from where do they originate? And the answer is that 90% of these emissions are due to the use of fossil fuels. For example, we use diesel, natural gas, coal, and this causes these increased emissions. So this increased atmospheric carbon dioxide levels caused the well-known to all of us global warming. And the global and land-only temperature in the Earth of last July was already 1.4 Celsius degrees higher compared to the previous century. And this is of great impact because it is expected to have catastrophic impact on biodiversity, ecosystems, human health, food security, water supply, and economic growth. So as you can understand, there is an urgent need to strive towards net zero global anthropogenic carbon dioxide in order to suppress this global warming. And to address this climate change and its long-term multidimensional impacts, the Paris Agreement aims to limit the global temperature increase below 2 Celsius degrees, ideally to pursue efforts to limit it to maximum 1.5 Celsius degrees. And this agreement was signed in 2015 by almost 200 countries, which every 5 years have to present their action plan. And the overall goal is to reach a carbon neutral environment by 2050. And it is widely agreed that hydrogen will play a pivotal role in this low carbon transition, and it is foreseen that a global hydrogen market will be established in the near future. So to reach the goals of this Paris Agreement, it is obvious that we have to strive for renewable electricity. And among the various forms of renewable energy sources, the solar and the wind electricity are the most advanced ones. But even though they're advanced, further developments are needed for their widespread penetration. So to give you an indication, these are the numbers of 2015. The solar electricity generation installed globally was 260 more or less terawatt hours. And this of wind energy was something a bit more than 800 terawatt hours. And this is much lower than we really need, because the actual anticipated global electricity demand is, as you can see here, several order of magnitude higher. So actually, wind power alone cannot offer a complete solution. And that's why we have to focus a bit more on solar energy, because solar energy is the most abundant energy resource. And the 173,000 terawatts continuously hit the Earth. So we have more than enough. Now, the problem, of course, with solar electricity is the intermittency. So solar electricity is available during the day, with its peak in the midday. But our electricity demands are higher early in the morning and also in the evening after the sunset. So this means that there is a mismatch between the availability and the grid demand. And for this reason, we need to find ways to store this excess solar electricity produced during the midday, for example, so that we can use it in the evening. And there are many technologies for storing electricity, and you're all familiar with batteries, for example. And these technologies are appropriate to deal with the hourly intermittency, for example, the difference between a cloudy hour and a sunny hour, and also the daily intermittency, like explained in the figure. But when speaking about seasonal intermittency, then things change, because we need to store large amounts of energy for a long period of time. And there is where green hydrogen can offer a promising solution. So this brings me to the second part of my talk, where I'm going to explain what exactly we do in the research field where I work. So as seen in this slide, solar electricity can be supplied to a device which we call a water electrolyzer. And in this way, we use solar energy to split water into its compounds, hydrogen and oxygen. And this produced hydrogen can be stored. So in this way, solar energy is now stored in the form of chemical energy. And this solution can allow the storage of large amounts of energy and for a long time. And this green hydrogen, then, which is produced by electrolysis powered by photovoltaic, can then be used as a fuel in the so-called fuel cell devices. And likewise, we can serve our needs for energy and transport. And an important asset here is that when hydrogen is used as the fuel, the only product of this combustion is water. So with this example, we can see how we can make the energy and transport sectors greener. Moreover, this green hydrogen can be used also in industry and reduce the carbon footprint, because hydrogen is essential for the production of ammonia, which we need to produce fertilizers, for the petrochemical industry to produce our fuels, and also it's essential in steel industry. So of course, each step in this chain has its own R&D challenges, and we need to find ways to have reliable and low-cost solar energy at scale, of course. And then we need to decrease the cost of water electrolyzers. We need to find ways to efficiently and safely store and transport the produced hydrogen. And of course, we need to integrate the whole process. And to deal with all these challenges, efforts of scientists and engineers of various fields and disciplines is essential. And personally, I'm working on improving the efficiency and decreasing the cost of water electrolysis. So now this table originates from a literature review that me and my colleagues have authored recently. And I will not go into detail, of course, but the main message that I want you to pick up here is that there are various technologies available to carry out water electrolysis. And each of these technologies has its own characteristics, advantages, disadvantages, and challenges. But what is common in all cases is that the criteria for market penetration, which are efficiency, cost, and durability. So water electrolyzers are somehow complex devices, and they consist of various components. And each of these components is optimized individually, and then all of them optimized components are assembled together. And to do this optimization, we look at various properties, and some of them are listed here, for example. And here you can see the heart of a water electrolyzer, how it looks like. And we basically have two electrodes, the anode and the cathode, which are separated by the electrolyte. And as you can see here, electrochemical reactions take place, which produce hydrogen and oxygen. And we use electrocatalysts simply to speed up these reactions. So my work is focused on the development of novel electrocatalysts, which can be active, durable, and cheap. And now we're coming to the third part of my talk, which is how we do it. So I'm going to give you a bit the storyline of electrocatalyst development. So of course, the first step is to synthesize the catalyst, and this we can do it with various methods. And once the catalyst is synthesized, then we carry out a screening of its performance by testing it at simulated conditions. And then these experimental results provide input for modifying appropriate the catalyst synthesis, and therefore we have a feedback loop. And this is also typically supported by theoretical computational studies, which can provide useful insights for us. For instance, they can help us to link chemical properties with catalytic activity, or to interpret our experimental data, or to predict promising catalyst materials. And once this part is done and we end up with some promising materials, then these materials are produced in realistic 3D electrocatalysts, and they are tested at realistic conditions. So this performance assessment typically involves measurements in a single cell initially, and then in a stack. So here I'm just giving us showcase 2 examples of our success stories. At the left-hand side, you can see how we successfully replaced a high-cost platinum-based catalyst by a cheap and abundant catalyst based on the transition metal phosphides. And at the right-hand side, you can see how by novel deposition methods through our collaborators, we managed to increase the platinum utilization by 30 times. So for those who are familiar with scientific publications, you can find further information about these works in the articles that I'm listing here. And to close my talk, I would like once again to point out that the fight against climate change is a top priority. And to realize it, the support of everyone is needed. So all of you can help the environment from home by implementing small changes at your lifestyle, like recycle, eat sustainably, travel responsibly, conserve water, save electricity. In the meantime, scientists and engineers of various fields are doing their best to generate ideas, innovations, and insights in order to offer new technological solutions in the whole chain of processes that we described today. And so specifically in the field of water electrolysis, where I work for producing green hydrogen, the current costs of this technology are currently high, and so high that the market penetration is still low. However, it is expected that soon we will be able to reach the goal of $1 of kilogram per hydrogen by 2050. And how can we do this? We have to implement a combination of cheaper electricity, renewable electricity, by decreasing the capital cost of the electrolyzer, and that can be done via the use of cheaper components and also by the standardization of manufacturing procedures. By optimizing the efficiency of the electrolyzer, and basically that means to use less amount of electricity to produce 1 unit of hydrogen. By increasing the durability of the electrolyzer, because this can allow us to extend the system's lifetime and thus spread the capital cost over a longer period of time and over larger amounts of produced hydrogen. And at this moment, I would like to thank you all for your attention, and I would like also to thank the organizers for inviting me to give this talk today. So thank you very much.
Thank you too, Fenia. Thank you for keeping exactly on time and for being so, I think, precise, but also explanatory for everyone to understand why this is important.
Thank you.
Thank you.
Good, thank you very much. Maybe before continuing, I will mention that you can type in your questions either at the chat or at our form on the website. We'll be here. We're not taking questions right away, but we will have plenty of time to discuss it with all of our speakers a bit later. So please don't be shy, go on. And now I would like to present you the next speaker, which is Professor Eleni Chatzi. So Eleni is an associate professor and chair of structural mechanics and monitoring at the Department of Civil, Environmental and Geomatic Engineering at ETH in Zurich. She received her PhD in 2010 from the Columbia University from the Department of Civil Engineering and Engineering Mechanics. at Columbia. Yeah, I mentioned that. So she has recently completed an ERC starting grant, the project Windmill, on the topic of smart monitoring, inspection, and life cycle assessment of wind turbines. And her work has been awarded in 2020 the Walter Huber Research Prize by the American Society of Civil Engineers. And apart from all of that, I want to say that I'm super happy that we have Eleni here. She actually started TTH by the time that I was also there studying. And I remember until now the rumor that first arrived before Eleni that there is the youngest, is that true, Eleni, actually, the youngest ever woman professor hired at TTH, and this is a civil engineer, and this is a Greek woman.
Yes, I was the youngest hire in general for men or women at the time. I don't know if anything changed since then, though. It's been 11 years now. So.
There you go. So this woman is Eleni. Yeah, looking forward to listen to you. So Eleni, the floor is yours.
Thank you very much for the invitation and for giving me this opportunity maybe to share my research and maybe discuss also aspects that relate to women in STEM. What I will present here comes from the domain of civil engineering and specifically the focus of my group, which is on structural mechanics and monitoring. Maybe a small overview of my group, which was formed when I moved to Zurich from Columbia University in New York in 2010. And which touches on a domain of civil engineering, which is rather interdisciplinary in nature, which has led to a group that is also quite mixed. So we have civil, mechanical, and electrical engineers that are members of my group, which is now varying in size, but more than 20 group members are engaged in these domains. Maybe to give a bit of a background as to why we're in this domain. In fact, we're not exclusively dealing with wind energy infrastructure, we're dealing with infrastructure in general, which is defined to be the host of our resources and networks that make our mobility, exchange, and exchange of goods, as well as the hosting of main resources possible. Of course, there is another definition which I very much like to use. Let me see if I can share this. So this would be the one over here. Anything that can be destroyed in an action movie is also what maybe you see often defined as infrastructure. But the reality is maybe a bit different in actual discussions and within our perspective of how we deal with infrastructure. This is mostly defined as a passive system, when at the end of the day, these structures or constructs are in essence live. They're organisms that are interacting with their environments. They are experiencing motion, deterioration and aging, prone to extreme loads and accidents, which oftentimes lead in accidents or catastrophes that could come with great economical and social consequences. And in order to deal with this problem in my group, we're researching ways to come up with information that come from these systems and which could actually help us anticipate, prevent, and cope with damage or deterioration of the condition of structures. And we're using a premise that draws from the equivalence of a human organism. Again, we're treating structures as active or living organisms. And we're trying to derive information by using sensors that can transmit or convey diverse information on a number of quantities that are critical for us to understand conditions such as force, displacements, static or dynamic response, the environment, but also the loads in which these structures are exposed to. And the reason or the purpose for gathering this information is for us to be able to assess what is called the health, but in fact the condition of these structures in a way that allows us to make decisions that possibly also prevent the catastrophes that I referred to before. And to do this, we're dealing with the chain, the structural health monitoring, as it is called, chain, where we start from aggregation of data, and this typically takes place with low cost and easy to deploy technologies. We often use accelerometers that our sensors are as cheap as a few, maybe euros, that you can even find today and deploy in bulk in the structural systems, operating structures. We're then using this information in combination with models so that we receive, or rather we distill the information in something that is interpretable with respect to performance. And by performance, I mean the condition of the system, whether it is healthy, as we mentioned before, or whether it is actually subjected to damage and deterioration that is possibly evolving. And at the end of the day, we're trying to use the indicators that we extract in this previous step to support decisions on what to do next, how to maintain, how to operate and optimally manage these systems and their collection. So the fleets of bridges, wind turbines, and so forth. In this talk, I will actually focus on what we do for wind energy infrastructure, because this is also a theme of this meeting. And perhaps this kind of infrastructure is the one where the need to use such systems is quite prominent. And I say this because the challenges that are involved are, on the one hand, the rather reduced lifespan of these systems. For example, to give you an analogy for buildings, or rather for bridges, the nominal life of these systems for which they are designed could be as long as 100 years of age. But for wind turbines, we're talking about 20 to 25 years, which when combined with the costs that come for their operation and maintenance, basically implies that the return on investment of these systems is not easy to make. And so what we would need to do would be to make sure that we can extend this nominal life in a way that gives us more, allows us to exploit more from these critical infrastructures. Now, this is difficult to do because we're talking here about not really a structure, but a hybrid between a structure and a machine that is subjected to quite high loads, adverse conditions, often leading to let's say not accidents, but critical damages that might compromise the performance and the continual use of these systems. Now, to cope with this, as I mentioned before, it's already known in this domain that we have to somehow gain observations, measurements, understand the condition of these systems. Maybe the most typical way to do this is traditionally with visual inspection, which really means you actually have to hang a person oftentimes for a blade, or you have from this blade, or you have to have them climb on top of a turbine to extract information. You might even have to do this with more costly and targeted instruments. And at the same time, in this domain, it is typical to also have permanently installed instruments that convey some information that relates to the power production of these systems that is quite critical to follow. What we would like to do in the context of what I explained before is to use structural health monitoring, so permanently, in fact, deploy these cheap and easy to install sensors that can tell us or can provide information about the structural condition of these systems. And we would like to do this by fusing these aspects of the chain that I presented below, so physics information together with data, to understand how to best manage these systems and extend their life cycle. In a way, we're trying to produce or deliver a sort of smartwatch for these kinds of systems, where you can supervise, condition, understand the models that best describe their behavior, and provide intelligent diagnostics and prognostics for these systems to anticipate failure. We do this motivated largely by an ERC starting grant that was awarded in 2016, which was just a few months ago completed, where we bring these entities together, physics-based representations, together with data that we aggregate from these low-cost sensors that we deploy in different aspects of these systems, in order to assess critical quantities that have to do with condition, such as fatigue, but also be able to provide these diagnostics in the short and long term about the performance of these wind energy structures. Just to give you a bit of an idea, what we try to do with data alone, first of all, data can take us oftentimes in domains where models, our predictive models, do not have much of capacity to predict phenomena. And this is true for complex phenomena such as the interactions of wind turbines within a farm and how their geometry and placement influences the distribution of flow within the farm. This is very difficult to model and requires a number of assumptions when you try to do it with physics. But when we do it with data, it turns out that we can actually construct how the flow is and how this, in fact, affects the fatiguing, the condition that I was referring to of wind turbines within the farm. And we use this information to better understand how to design wind farms, but also better understand how to operate the more heavily influenced turbines. A reason why it is not easy to work with data on this type of challenging systems is that if you look at them and if you look at the data that is aggregated, we see this modulation of what is really the dynamics of a system. And this modulation is true not only within short intervals, this is just 10 minutes here, but it's also true when you look at the performance of these systems along a longer duration, such as a month. And so this modulation of these lines means that there's effects that really come from their environment that are influencing the way in which the systems perform. And for us, the task to predict condition is, of course, harder when this happens. To do this, we try to bring in data from the structural response. Together with data we aggregate from the environment, we try to form models that are hybrid, that operate on the synergy of both of this information. And once we are able to do that, then we have predictive power, which we can use for condition assessment. There's different methodologies that we have developed to be able to do something like this. And I'm not going to go through the details, but it's something that for those that are interested in such systems can find in recent publications. Just to give you the essence of how this operates, we typically rely on data-driven models that can try to, that are trained for a sufficient amount of time. And once trained, are able to see whether we have a deviation between our prediction, what we expect and what we measure. And this is the quantity, the outliers rather, of this prediction and measurement is what we try to treat through probabilistic analysis and clustering tools, so that at the end of the day, we can deliver engineers with a prediction as to how a system performs, whether it is indeed doing as predicted, all is well, whether we in fact have a red alarm, which means something is going wrong when we should expect it to be operating in smoothly, or whether in fact we're in a situation of a yellow alarm. This means we cannot really say that something is wrong, but something is certainly off, either with our predictive capabilities or with the system on site. And this we use to direct decision. How much do I have?
Two more minutes.
Okay, great. Maybe just to use this last minutes to mention that while this is a lot of this is what we can do also with data alone, at the end of the day, the data is not enough. So in fact, in our group, we also try to go a step further from the exclusive use of data, which typically gets you here, diagnosing if something is wrong with the system. The moment you want to understand or predict what happens next, you have to fuse in physics for this prognostic task, which is what has led us to develop a set of methodologies for what we call hybrid models, which is the use, synchronous use of physics with data, and which is what allows us to do this virtualization, sometimes referred to as digital twins of these operating systems. We have a number of methods. A lot of the tools we need to develop to do this have to do with the reduction of physics. But at the end of the day, what it means is that we have to be able to predict response, even when it is dynamic, in a fragment or fraction of seconds. And we do this so that we can use these reduced representations to understand damage, to predict deterioration, or enhance our understanding of these systems. Since I don't have a lot of time, let me go directly here, which is what we do as a last step. We would like to support decision. And this means we have to bring all of these prognostic tools and predictive indicators together in a platform, which is what we have designed or devised for these systems. Through cloud computing and artificial machine learning algorithms, we try to decide what the next step is, depending on what our system predicts on the basis of data. At the end of the day, we want to avoid or at least supplement these activities that would need you or would need an engineer or an operator to send someone on the field, possibly in remote and offshore locations, to understand whether something is wrong. And this complements our vision. So as I mentioned in the beginning, we're not only working with wind energy infrastructure, we're working with civil structures in general. And what we're trying to do is instill perception and cognition through the use of these measurement and monitoring technologies to take infrastructure forward from what we initially perceived as passive or inanimate to or towards something that is active, autonomous, and self-aware. So with this, and with acknowledging a lot of the support that we have had during the years to make this happen, I would like to close and give the floor to the next speaker. Thank you very much.
Thank you, Eleni. Thank you so much. To everyone, keep the questions coming for later. And I will now introduce you to our last speaker, which is Maroula Tsagkari. Maroula is a PhD candidate at the University of Barcelona, the Department of Economics. Her work focuses on energy communities, self-sufficiency, and energy democracy. She has a master's degree from in environmental science, policy and management from Central European University and the University of Lund, and a bachelor in biology from the National and Kapodistrian University of Athens. She has been awarded scholarships from FI GenCat, I hope I pronounce it well, and from the Levendis Foundation. So I'm really happy that Maroula is here. Maroula is doing some great research on social, political, economic aspects of the energy transition, and she has been working on degrowth as well, which is a concept I personally find very beautiful and very promising for our future. So looking forward to your presentation, Maroula. The floor is yours.
Thank you. Let me share my screen. Can you see?
Yes, perfect.
Perfect. Let me make these percentage. Okay. So, yeah, thank you so much for having me, and thanks for the introduction, Natasa. I'm Maroula, and as you heard, I have a quite interdisciplinary background. I actually studied biology, so you may think, what is she doing here? She should have been in the panel yesterday, but I reassure you, I did not mix up the schedules. And actually, I started by working in the biology department. I did my undergrad there. And I have to admit, I was a little bit fed up with the lab work. I just felt it's not for me. So I followed the path of ecology, studies in ecology and population, which is a quite undervalued field of biology. However, there I learned enough to realize the importance climate change plays nowadays in our lives and how much we've stretched the biophysical limits of our planet, possibly to an irreversible degree. The trillion tons of carbon dioxide that we put into the atmosphere by burning coal, oil, and gas have heated our planet, bringing us into a new climate reality of increased floods, storms, and droughts. We face that very clearly this summer in Greece with all the wildfires. Plant and animals have for a long time faced the results of our actions, and now I think it's time for us to taste our own medicine. If we continue down this path, we will face rising oceans, collapsing food and freshwater supplies, and probably loss of hundreds of millions of human lives. So for this reason, I decided to focus my research completely on the environmental policy and management research in an effort to find solutions and fight against climate change. So by the time I finished my master and I was about to start my PhD, it was, I think it was 2018, and it was what I consider a turning point in the discourse around climate change. It was the time that Greta Thunberg started School Strike for Climate to pressure the governments to meet carbon emission targets. Her small campaign, actually she was just alone sitting in a square in Sweden, soon inspired thousands of young people around the world to organize their own strikes. And by December 2018, more than 20,000 students from UK to Japan had joined her by skipping school to protest. Nowadays, we see a new generation of scientists and of activists that is insisting that we need to evade the mortal threat of global warming, and at the same time, they're blaming the elders for stealing their future. So just like this, climate change and the ways we can prevent it and live sustainably in our planet left the academic circles and became a political and activist slogan. And what is well known is that in order to combat climate change, we need a quick energy transition to renewable energy. In fact, in a couple of years, as the IPCC reports say the past years, we need to go from burning fossil fuel to zero emissions. So here's where renewable energy comes into the picture. Renewable energy has been praised not only because it can produce clean energy, but also because it can bring closer production and consumption. Meaning we don't talk anymore about like fossil fuel produced somewhere far away from our house, or this complex electricity market that you have no idea what you're paying for when you get your bill every month. Now, actually, we have electricity that can be produced on your rooftop. It can be shared with your neighbors, saved on your own battery. Actually, you can sell it or exchange it through a peer-to-peer model that is also known as energy communities. And actually, we have come a long way the past years, I have to say. Most of the EU countries reached their 2020 targets for renewables. And in many countries worldwide, like Spain, Italy, Australia, Chile, solar energy is actually cheaper than the grid average. It was the UBS, the world's largest private bank, that told its investors a couple of years ago that large centralized power stations are on the way out in Europe. And the way forward, it's rooftop solar panels and home energy storage. So renewable energy offers us a way of hope in our climate crisis, in these doom and gloom times we're living. And they have the potential to build a new decentralized, democratic, sustainable future. Energy systems are nowadays examined not only as technical systems, but also as social systems. And the energy technology, as any form of technology, is not neutral and does not dictate the direction of energy transition. For this reason, this emerging field of energy transition is very interdisciplinary and complex, I would say. So where I currently work, we combine many different disciplines. There's a techno-economic school of thought that uses economic and engineering models to examine the market-regulated flows of energy across sites of production and consumption. We also have behavioral economists that try to predict and motivate people to take certain actions. We have political scientists that try to predict how institutions and policies will adapt to meet this new reality. And also environmental scientists that try to see how renewable energy affects the surrounding environment. For example, waste management or the water cycle, soil quality, etc. So just briefly to explain what this means from my personal experience, what I do is I research renewable energy projects post-implementation, which means that I go there after the project is already installed and it's operating for some years. So what we try to see with the people I work with is how the project has affected all, like the community and the three pillars of sustainability, meaning the economic impact, environmental impact, and social impact. We do this, well, we follow a combined method approach, which means we talk with the community, we talk with the managers, with the politicians, and then we form some models and try to see what is the actual impact the project has on people. We also focus on some specific groups that we think is very important to include, like for example, women or older people, immigrants, etc. So overall, I have to say that we examine the energy transition not only as a solution to climate change and a way towards a sustainable development, but also we focus on actors that have been overlooked in this transition. So before I close, I would like to tell a short story. When I was about to start my PhD, I went to a funding committee that were about to give me a scholarship and then told me, oh yeah, amazing. That's a very nice interdisciplinary project, but you need to have some advisors, mostly from the field of economics and engineering, that will guide you, because of course one person cannot know everything. I got one of my potential supervisors and I tell him, oh, well, the committee told me this and that. And he's like, oh, yeah, don't worry, I'll just send you a list of potential collaborators. He sent me a list, and what do I see? All white men. There was not even a single woman on this list. I just couldn't understand how and why would we expect that we understand the specific needs of women or marginalized group if we don't include them actually in the process. Don't we have enough science of this, science of white masculinity? Don't we want our clean new energy system to be designed and operated in a new form and not under the same hegemony that created this mess at the very first place? And it was about this time that I saw this great quote from a CEO, Christine Lins, and she said, if more women were working in the energy field, the energy transition would advance more quickly, but also more inclusively. And I think that is very important. Which brings me to my last slide. I just want to stress that women account only for 22% of the labor force in the oil and gas sector and 32% in renewables. And women are not underrepresented only in fields that we initially maybe expect, like engineering or economics. They're also underrepresented in policymaking, in advisory positions, and even in the renewable energy communities. Sustainable energy transformations are social transformations, and we need women to help us rethink how we share and how can we redistribute these common resources. That's why I would like to stress that it's very important, and we should all motivate ourselves to be involved more and more in the energy transition. So yeah, closing, I would like to say that climate change is a man-made problem and must have a feminist solution. And thank you so much for having me.
Thank you, Maroula. Thank you so much. I hope, Kelly, you agree that's such a great way to conclude the first part of our session with the speeches. Let's take a 10-minute break to get some rest, to rest a bit our eyes, get off from your computers for a while, and let's get back at 2:30. Kelly, is that okay?
Yeah, I think that's perfect.
Great, and let's all back at 2:30 with all our speakers to discuss your questions, our questions, and some of these important topics that were raised all along this first hour.
Thank you so much. See
See
you in
you
10
in a bit.
minutes.
Συνεπέστατες όλοι.
So maybe give another 1 minute, but all the participants are in.
Yeah.
So I know that Natasa and myself had a lot of questions for you to begin with, knowing your expertise and backgrounds and everything. But I think we will start some cues from the audience. And I feel like there was a question on the personal responsibility being a long shot. But I feel like it's quite important as well. So if you could somehow, like if I would ask all four of you, what would be the one most important thing that we should do to save our future, pretty much? What would be it? Maybe Eleni, do you want to start?
No pressure, it's important.
Yeah.
Sure. I mean, I should maybe first offer a disclaimer in that what I presented is more focused on the engineering side of structural reliability and maybe sustainability of these systems. But even there is actually the element of responsibility in the sense that when constructing our built environment, we have to now, as we are aware of the limited resources that actually are available and the impact that these resources could have for the environment, we have to do it in a way that is indeed responsible. So it is not only about digitizing infrastructure or using the latest trends of data, and a lot of it is what I also showed for our research, but it's also doing it with a view to delivering systems that are actually respectful of the future, that are respectful of their surroundings. So I think responsibility, as although it is a long shot, it's something we have to adopt as a culture.
Mm-hmm. Thank you.
If you allow me, yeah, just to follow up also from a bit of understanding, Eleni, you mentioned that the wind turbines have a reduced lifespan compared to other infrastructure. May I ask, why is that? And is that like,
well, they are relatively, I mean, wind turbines actually popped up only in the recent years. They're not as old as other engineered systems that we're used to having built and also have long tested standards for. And additionally, they are a hybrid, as I said, between a structure and a machine. They have components that are very easy to wear, to deteriorate. So the short nominal lifespan is often linked to whatever is the weakest link in the chain, because we're not yet aware of how we could also do replacements or substitutions of components while still maintaining the remainder of the infrastructure could possibly go longer. And I think once we start to understand these things, possibly through monitoring, as I described, then it's easier to, or very soon we would have different types of lifespans also for these relatively young systems. You should imagine that it's only now that the first generation of these wind turbine facilities is reaching that end of their useful life for the most part. So now we're met with the question what to do next.
So I don't know, Maroula, do you want to also tell us about the one thing that you would suggest that we all do?
Yeah, I would say get informed is the most important. I understand that not all of us can take all the possible actions. Maybe someone lives in a city and cannot install rooftops, or maybe someone just doesn't want to be a vegetarian. But it's important to know the impact your actions have and try to think about what you can do. Like even small things count. Don't use your air conditioner and have your windows open, So I would say just get informed and try to think before any action that you're taking, the impact your action has on the environment.
I don't think that this is hugely important, really. And then I see another question that was on remote work during the recent pandemic. And I can see that Eleni has already answered from like an academic point of view, but maybe Fenia, would you want to tell us more from, you know, a company point of view or a research point of view?
Maybe shall we read the question for the ones
Yeah,
on
so
Facebook?
the impact of
or-
remote work on the environment during the recent pandemic.
Yeah, clearly that had an impact. True, that's true. Also on our productivity sometimes though. But yes, due to the pandemic, obviously people had to travel less. So then, of course, that had a great impact at the carbon dioxide emissions and like the fuel emissions of the cars. So yeah, that went better. But on the other hand, that's not the solution that we always work from home, let's say, to suppress these emissions. So I mean, scientists and engineers have to find technological solutions so that we can still have this lifestyle and we can travel in a clean way. But yeah, on the other hand, until to reach these solutions, I think that we just have to change a bit our lifestyle. Use public transport, for example, ride the bike a bit more, or carpooling or things like this. So yeah, that's what I would say.
That's I think that's a major part of the solution, probably. No. And what about, like, I know that all of you have very different fields, but what would you say it's one major advancement at the moment that has happened in your field? Hrissi?
You mean during the pandemic era?
Not necessarily, just lately, because I know that we tend to follow, like Eleni said, we tend to follow trends, maybe. So yeah, I mean, generally lately, maybe the last 5 years or so.
Yeah, for us, I have already mentioned that in my talk, that the development of analytical techniques is very important for people who want to study this field. For example, if you want to study microplastics, you have to have a way to analyze for them. And development of new analytical techniques that are also cheap. That's very important. It's one of the major things that have happened in my area.
Eleni, you wanna?
Yeah, I mean, for me, I also mentioned a bit of this during the talk. I mean, from the point of view of a civil engineer, where you had most things typically designed and then anticipated by hand calculations. For us, there's two things that made a difference. First of all, the development of technologies that are tangible. So now actually there are school kids that are using Arduino boards to develop sensors. So I don't have to convince engineers coming to work with us that they have to also get their hands dirty with technologies. They're sort of already in the culture of doing that. And the second aspect is the advent of computing. So now we have more computational power to use the models that can describe the physics and to combine this with the measurements that we can obtain. So this is what has allowed us to make some jumps actually in the last 10 years in this domain that I'm in, which is structural health monitoring.
I think there was another question, but I would want to ask all of you probably, what do you think are the main challenges for all of us to, as a scientist, let's say, or as engineers, to transition to a more sustainable future, or for the energy transition generally? Maroula?
Well, yeah, that's a tough question, but I would say as a scientist, the most difficult is work actually with the people, because it's one thing to design amazing technological systems, and it's another thing to actually convince people and convince the communities to make this change in their lifestyle. And we see very often communities reacting to to the energy transition. In Greece, it happens a lot recently. So we need to find a way to actually communicate with people and tell them why energy transition is important, and also listen to their needs and to their complaints and try to take them into account when we design new systems and new projects.
Fenia?
What do you think? Sorry.
Sorry. Natasa. Yeah, go ahead.
No, just to follow up, and why do you think it is that it is difficult to engage the people? What is, let's say, community? What is it that holds back the communities? Is it like the lack of knowledge, of information? Is it the resistance to change in general? Is it that we are asking too much of the people?
Well, yeah, that's a very big discussion now, because initially it was believed that these communities mostly react because of this idea of not in my backyard, that actually they didn't have the knowledge, or they just didn't want renewable energy close to their towns. But now actually it's been proved that these communities are very well informed in many of the cases, and actually they know what they're talking about. So what I've seen from my personal research is that communities tend to accept more renewable energy projects easier when they're involved from the beginning. So if you're just go and install some windmills, and especially a really big industrial windmill park, communities are going to react. If you actually work with them and discuss, okay, where should we install the windmills, participate in the project design, in the project assessment, then communities, when they feel included through a democratic process, I think also accept the projects more.
But who do you think holds the responsibility of, you know, making them know and involving them and everything? Because it's quite tricky, you know, if to involve like communities in designing a project. Yeah,
that's multi-level, I think, like approach. For example, in the case study that I'm personally working on, which is Tilos Island, and they do have a very like innovative renewable energy project. It was the municipality, but it was a very big environmental organization in Greece that talked with the people, held like public consultancy with questionnaires. Also the operator, the HEDNO in Greece, you know, all these actors were involved and worked with the community. So I think it's to start from all the levels, from the national to the municipality and to the technicians that are involved.
And Fenia, what do you think? I guess Maroula answered that in a more like intersectional answer, actually, or solution.
What I want to add is indeed to improve public awareness, of course, is important. And yes, Maroula said that is multi-level, but I think that there is already a lot of progress on this, like a lot of open public events, and that's good. And scientists have, of course, to learn to speak the language and explain the things in a very simple way so that the general public can understand. What I think is also important that the problem of climate science, let's say that it's more obvious nowadays. So I think that if we were trying to describe these things like 10 years ago, probably this was not so much relevant to the people, or they would think. But now I think that more or less everybody has really understood that there is global warming, and you can already see it, I suppose, in the countries where you live, that the weather is changing. So I think that this is also very good because it helps people to understand. And then going to the solutions, like what engineers I think have to do is, on the other hand, that the solutions that we will offer should be very simple for the user. So if the people have to use or implement something that it's very time consuming to learn how they operate, they will of course push it away. But if we give simple solutions that everybody can operate, or you know, that it's also safe, then that also plays a big role. So I think automation is also something very important.
So from your research and your point of view, do you think, like, I thought you would tell me, you know, we don't have good materials, or we don't have enough people, or, you know, this kind of things. So you think the challenges are actual how to get people to use them, not really how to make the best fuel cells or the best batteries available?
I think that this is coming, and seeing like the progress that there is on the research last years, I think, and the predictions say that we will be able to reach the goals of hydrogen production, let's say of $1 US per kilo of hydrogen. So yeah, there are challenges in terms of materials, especially a lot of them, but there is also a lot of progress. The good thing is that we have for green hydrogen production many technologies. They are at different stages of development yet, and each of them has its own challenges, but the progress is there. And there will not be one technology or one solution. I think for different end applications, at the end, different technology will be applied so that we will have a merge of these solutions. Yeah, materials, of course, is something, but I really see progress happening, and that's good.
So that's very good to know, really. There is one more question.
Can I add something?
Yes, of course, of course.
Okay, I agree with Fenia that giving simple solutions to people is really helping to adapt a new technology or a new idea. But I'm afraid that the problem is not that simple. For example, sometimes when we give solutions for environmental problems, it seems that doing one thing is enough. But the problem is it's not, we should not be, how to say, relaxed about it. That, for example, we go and clean a beach, and so we have done our share of our responsibility. We need to think in a more critical way, and of course we are responsible for our habits, but if, for example, I will go back to my own field and say, for example, for plastic pollution, if you don't have the recycling loops to return the products, it's not your responsibility, it's the responsibility of the industry. So we need to ask for a better treatment as individuals. I think that's what, especially for Greek people, it's a way of treating ourselves, have a better estimate for ourselves, and ask for a better life. And I think it's very important.
I think I will just ask maybe a similar question.
Eleni wanted to.
Maybe just to say that I agree with raising awareness, which is quite important, but there are some things that have to be coordinated and instigated at a higher level, maybe even at an international level. So to this end, to have the relatively recent Sustainable Development Goals defined by the United Nations has made a tremendous change, also for defining European calls for research, also for aligning the programs, not only for research, but also for applied developments with these goals. So there are a few things that need to be done at that level. And I think this is it's an excellent example of what could motivate change.
Well, yeah, my question was pretty much that. So who do you think is really takes the responsibility for this? How do you think? So Hrissi, you said we should ask for this, but ask it from whom, pretty much. That's also a thing. I want a better life, let's say, but people usually don't know where this come from.
Yeah, that's why education is very important and awareness is very important. And of course, you will go to your nearest and start from there and go up, let's say.
And if I may add a bit or twist a bit the question, do you also think that there are also, let's say, trends in research or in funding that also kind of give the directions of what is possible or what is doable? For example, in my case, for organic waste management, everyone is talking about prevention, don't do food waste, and it is so much research and the funds is going in there as if, if we don't throw out 2 slices of bread will change everything. So do you see these trends? Do you see this direction being?
This is true. This is true. There are a lot of money spent for research, and I think spent in a good way. Let's say going for trending, let's say topics, but. The thing is the legislation. If the findings of research is not followed up by legislation, the appropriate legislation, there's not much impact. And the thing is, you can get discouraged by the results. For example, people understand there is an impact from plastic pollution, but at the end you see that nothing is happening about it. Yes, there are a lot of money for research, but not any legislation that is follow up by how to say follow up by people who watch if this legislation is valid, if it's taking place.
Do you feel sometimes pushed to follow the trends? Like, because I know from academic point of view, like we want to continue doing research. So one of the main things is how we get that funding to do research. So do you feel like pushed or a bit, I don't know, disabled from the changes in the trend? Or because I know like there's at some point that everyone's talking about hydrogen, for example, and then someone, oh no, that should be coupled with CO2 utilization, talking from my point of view. So do you feel kind of pushed to do, you know, what you're kind of, yeah, those trends, let's say?
Maybe I would say that in general, there are these trends and there are these themes that are actually put in place from the examples that I showed before, you know, organizations that are responsible for distributing money for research, for instance. And I want to say that a lot of thought is likely going into these things. So I actually find these directives quite important for shaping research. This does not mean that one needs to be restricted in whatever, you know, these are usually areas within which one can also identify themselves and their research to belong in. It does not mean that you would have to follow exactly whatever is every time the catchphrase or the keywords that seem attractive. A lot of, you know, in my domain, this has to do with digital twins. So you see this appearing everywhere, but effectively what happens is many of the researchers are finding their identity and they are shaping their research to fit with the idea of this autonomous somehow supervision, which is a broader concept. My point would be that it's nice to have these overall directives, but likely, as Hrissi mentioned, what we're missing is the transfer to practice. So there are many ideas, but then what happens with their implementation is not so straightforward. And I think there's a lot of ground to be covered by the creation of spin-offs and startups. And I even think you had a dedicated session for this, which is quite important for this transfer of knowledge into practice.
Thank you. Let's try to get the conversation a bit more on the women part of the STEM here. First, Maroula, I would like first to begin by asking you, because you mentioned it in your presentation, in the end, like how you mentioned that you also research how groups like women or elderly people or immigrants are differently affected by renewables or differently involved. Can you just tell us a bit, maybe specifically about women? What does it mean? How can different projects affect differently women?
Yeah, so that's also another trend now in the energy transition studies and gendering energy transition. And it starts from the fact that women have different energy needs than men. So for example, women very often are the responsible one for care or cooking, or when they work in some small shops, they're very affected, there's no reliable energy. And of course, in European Union, they're the number ones who suffer from energy poverty. So I think it's very important to tailor all the energy policy to women and other marginalized groups. In my personal research that I did in Tilos, what we actually found is that women tend to evaluate lower the projects compared to men. So that's because some of their aspirations, when we asked them, okay, what did you expect from the project? They said climate change mitigation, reliable and clean energy. They had these long-term aspirations that are very often discussed that women are more environmental conscious than men. And when we told them to assess the project, they said we didn't have any economic benefits. We don't believe the environment was benefited as much as they promised us. We didn't see any improvement in our daily lives. while on the other hand, men were, yeah, my number one target is to be autonomous from the mainland, self-sufficient, and we achieved that. So we see I'm not saying the one is better than the other, I'm just saying they have these different needs and priorities, and when we design policies, we need to take them into consideration, and also in the assessment of the project. That has been very much discussed in the Global South, and I think in Global North, we tend to think that with energy, it's gender neutral, and we follow this gender blind approach when we design and operate our technologies. And I think we really need to think forward a bit how actually women are affected by our technologies.
Yeah, exactly. The gender neutral, that it's actually never gender neutral, but just the male narrative, right? That we give it as gender neutral. Okay, and going to being a researcher, a woman researcher in engineering or in renewables, actually, we have a very nice question from the audience that is here. And maybe I would like to start from Fenia. So the question is, how do you advise younger females to achieve their entrance to renewable energies? And I will take it as renewable energies from your point of view, your field, your experience. Did you have to prove yourself twice? Fenia, would like to start a bit?
Yeah, just I was a bit lost. Like the question is how women can enter research.
Exactly, and in the field of the renewable energies, was it harder because you were a young woman?
Yeah,
and in what ways?
Yeah. I would say that all the engineering departments are mainly men studying there. So that comes first. Like I think that it's mostly a choice of men to follow this kind of engineering fields, I think. So I mean, I see it also in the students, like there is not 50-50 by no way. But then being a woman to continue with research, I think that now there are many policies, especially in EU, for a gender neutrality. So I don't think that being a woman is something that would keep you out of research. On the other hand, it's very much promoted to have women working in our research labs. And so I think that if you're really determined and you know that you want to work on something, I think that you will mainly be treated equally. And I say mainly because there is always this unconscious bias. So yeah, this is truth, and it's something that we cannot control. So that sometimes people would tend to trust maybe male scientists more. But this, I think, again, I think that in European Union, this is not the case anymore, and women are treated equally, I think. So if a woman really needs an opportunity, she will have it, at least in Netherlands, where I lived the last years.
And then why do you think that women are not that drawn to engineering? So we've seen
I think it's a matter of preference. I think it's the same when I go to my kid at school in NL and I see most of the teachers, they are females. I think it's just a tendency for female to choose maybe theoretical fields of study and men to choose more engineering fields of study. And I think that comes out of nature probably. But I think like if a male teacher wants to be a teacher, he will have an equal opportunity. But at the same time, if a female wants to be an engineer, she will have an equal opportunity to men, at least in NL.
Maybe I could
add jump in.
Go ahead.
Yeah.
Okay. So, I mean, I'm not sure if I would agree completely with this issue of nature, because there is a bias that goes into the culture, through different cultures, even from this global north. I live in Switzerland, and if you look at the way in which kids are raised, things are quite traditional. And it's still the case that, if you're a female and you like math, you might feel excluded because most of your friends will not like math. And this was actually something that was told to me from Swiss colleagues of mine. So it is actually important to also reach out to these younger generations, reach out to education at that level, elementary and high school, and already provide role models so that female students can see that you don't have to be male to be an engineer. And if you're a woman, it doesn't mean that you should not like math, because that's not what your environment likes. So it's not just about a conscious choice always. And this is what we have to work on changing. And at ETH, which is the institution I work with, there is this realization, and we try to do active outreach to those levels of education so that we can attract engineers or female in STEM.
Maroula, you had
Maroula,
something
yeah.
to add?
Yeah, I also agree with Eleni, and I totally believe it's not nature, but like nurture. And the very good example that when I, for a long time, I was thinking that I'm just not good at doing things with my hands. Like, engineering and everything, it's like building things, I just don't have the perception. And then, I started thinking about it, I'm like, okay, wait a minute, but what was I doing when I was a child? My brother was playing with Lego, with construction machines and things, and I was just playing with dolls, basically. So, it's something that I grew up not knowing how to do, and nobody ever taught me to actually do things with my hand because it was not considered a girl's thing. So I believe if we actually give both options, I'm not saying that dolls are bad. If a girl likes to play with dolls, she can do it. But if another girl wants to play Lego or construction toys, it should also be able to do it. And yeah, I think it's very much on how we raise our children.
So they say something here though. I think it's quite important to notice that we don't have to be, an engineer to begin with, because this is such a huge field that you can come to. So here we have, I assume, 2 civil engineers, 1 material scientist, 1 chemist, 1 environmental engineer, and a biologist. And we are talking an engineer panel, right? And we work on this. So it's, it's like the sky's the limit pretty much. And I think that's what we need to also tell our children.
Could I add something? Yeah, sorry. Second time.
Okay.
No, go ahead. Go ahead.
I would say that, sometimes maybe you may feel different, but that's okay. I mean, different is interesting. Don't think that you have to fit in a department. You can be different and bring new ideas, new discipline. And I think at the end, you will do what you like and don't care about what the others think.
Well, it makes everything much harder if you don't fit in, right?
Yes, but still, it's who you are. I mean, you don't need to change who you are to prove yourself.
Yeah. Eleni, you wanted to add something?
Well, just to add, from this limited pool of women that decide to go into STEM and engineering, you have to imagine that an even less, it's the number of women that proceed to becoming faculty in these domains are even less. And I want to add an observation that we have made over the years that, in fact, women do not tend to apply as opposed to their male colleagues, which means we need to have active recruiting strategies. We need to be able to reach out to excellent women and give them incentives to move and apply and evolve in their position, because it seems that, when they have the burden of a family, they will not take this decision on their own. So there is a reason for these incentives, for oftentimes these new positions that come out and are only oriented to women candidates. This is not because it's a discrimination against male colleagues, it's because we need these incentives to have excellent women in academia. And so I just want to make this clear, because oftentimes it's seen maybe as something that is bad, but it's not, it's necessary.
I want to just say here, and Natasa knows this very well, we have some awards for early career women through the symposium, and women did not apply in the beginning, and also we tried to reach out to a lot of them, and we got a lot of responses saying that, I'm not good enough for this. There are others that are better, and I think this is a trend for women to kind of think they're not good enough. I don't know if I would go mention the imposter syndrome, but I don't know if we think about it from so many different points of view and try to find to be the best of the best in everything. I don't know if it's that, or if it's the fact that we are taught to think that way and not go forward with what we want, or because society doesn't expect us to do that. I'm not sure. I don't know what your opinions on these are.
Yeah, for me, it's also a bit adding to what Eleni was saying before, it's just, yeah, incredible how much we feel out of place. That, for example, in cases where there is an active recruitment for women and they say, no, I don't do it because I don't want to have been recruited because I'm a woman, we ourselves ignore the unconscious bias that these things are trying to fight. It's as if we assume that without this, we have a meritocracy that doesn't actually matter, which is not the case at all. I think it's just all very deep, at least in my opinion, very systemic. So maybe, sorry.
And Natasa, I want to say that I can see in the chat that there is a comment saying that there was a limitation for applying because of the definition of early career researchers by the awarding bodies.
Okay.
And, you know, we said like we wanted to give acknowledgement, let's say, to early career researchers that don't get to be acknowledged that often. But through that, it was like 10 years from when you finished your bachelor's. 10 years, like there are so many women, right, that have finished a bachelor in biosciences, mathematics, physics, engineering, whatever. So we are talking about those 10 years. We're not talking about when I talked about the award example, but I feel like this is a general trend. Like, I feel it's a thing women do. And I can see it in my friends, in my colleagues, everywhere. Like, you know, when you're in a room and there are even like a few women there and someone tries to take questions, the questions will come from men because women don't speak up usually, which is something we need to work on, I think.
Yeah. So let's get, so tell us what has helped you, whether we believe it is harder or not, but what has helped you personally in the first steps of your career or in the later steps of your career to move forward, to climb up or to keep going? What was these things that helped you and that maybe you would advise younger women that want to be in the sector to do? Fenia, would you like to start?
Yes, so yeah, in relation also with what Kelly mentioned earlier, yeah, I think that self-confidence plays also a role, that you have to believe, you have to be the first one to believe to yourself, let's say, and then you have to believe that you're strong and yeah, evaluate correctly your skills, if I might say, or your strong points. But then you have also to be determined, of course. So if you really want to succeed, you have to be determined and just work for your goal. And I think at the end, yeah, maybe as Hrissi mentioned earlier, if this is what you want to do, you don't have to think that, oh, I am a woman and how this will affect me. If you just stop thinking of it and just think, okay, we are all humans with equal opportunities, then that's also kind of helpful. So just be determined and try not to think that you're different or you're a woman, and just, yeah, treat yourself equally, and then the others will treat you equally also, I think.
Okay, any Hrissi, any tips from your side? It's any reactions?
Yeah, for me, it's also very hard work, responsibility for your research field. What you do it correctly. And I think for me, what mattered a lot was networking with other scientists, as it was already mentioned by Kelly, that if you work in this field of environment, you cannot do the work by yourself. You need many different disciplines. And then the more you networking, the more different opinions, different ideas you get, and this is very helpful for improving your science.
Maroula, from your side, you are kind of in your first stages maybe, or earlier in your career, but Is there something that you find that is helping you or to move forward, to move up? Or
Yeah, I think, of course, yeah, hard work and dedication are very important, but I also think on the same line with what Hrissi said, it's very important to have a supportive network. Like try to find people that will support you, whether this is family or friend, but also other scientists. And even if you're in a department that you don't have any women to have as a role model, just reach out in another scientist in another department. Like, look, I'm just starting my career on this. I found you. I've seen you've done a great job. Any tips? Just don't be ashamed to reach out to people, because all of us want to help each other. I think academia has passed this like old style of being competitive, and especially as women in science, I really think we want to support young girls. So I definitely think you need to like do this step and try to create a supportive network.
yeah, I totally second that, and it's also one of the things that we are actually doing in Greek Women in STEM, trying to do with the mentoring and with showing the work of women, that they can serve as mentors, as role models.
Yes, that's something actually I think we're almost there. So I wanted to say something to second what Natasa said. That's something that we are really trying to do in Greek Women in STEM, is to be there for younger girls and boys, really, but generally to be there for younger people, because we think that mentors are very, very important in our lives, and they shape us a lot of the times, I think. So we'll leave in the chat for everyone our mentoring program. If you want to be a part of it, you can be there as a mentor or a mentee. Of course, we have more than 40 mentors at the moment from all around the world, both men and women. And I've also wanted to, of course, thank all of you for being here. I think we could continue this talk forever and ever, really, and it will never be enough. But thank you so much for being here. Yeah, Natasa?
Yeah, I just wanted to say that now, almost right away, you're allowed the PP break, but right away then please be back for our networking session, which is actually a real Zoom room where we can meet each other and go in breakout rooms and keep discussing on these things, like really also with people that are participating. That will be for half an hour or so. That's an invitation for the speakers, for the attendees, for anyone who wants, if you want and if you can. So this is happening right now. The link is now on the chat. Please follow that. And other than that,
sorry, Natasa, I want to say that there is another session after the networking, and this is the global link, the one that you're here, but the networking one has a separate link, just to make that clear. It's the one that came in the email later, a few hours before.
And other than that, please do follow us on we are very social. We have LinkedIn, Twitter, Instagram, Facebook. If there is something else, we have it for sure. And then
everything under the sun.
Exactly.
Oh, yeah.
And so we keep discussing about these things. We keep lifting each other up. We keep helping each other and try to make it easier for us all. There will be social events soon that we'll also be able to meet each other again. So thank you very much to the speakers, to everyone.
Thank you for the invitation.
Yeah,
Thanks for organizing.
Thanks a lot.
And congratulations for this initiative.
Thank you so much.
Bye.
Bye-bye, everyone.
Hi, everybody. Good afternoon. It's great to have you on today. This is the final session of the symposium, the first international symposium for women in science and technology. It's been an incredible 3 days. I'm very happy with all the talks we've seen so far. All of our speakers were amazing. So I don't want to delay anymore. So for this session, we're going to focus on advice about career choices and career paths. We're going to talk about industry and academia. We have a great panel of amazing women and 3 really incredible speakers. The first speaker of our lineup is Fenia Sapountzi. I'm very happy to introduce Fenia today. She's an incredible immunologist. She's from London. She's a friend of mine for pretty much the past decade. And she's going to talk to us a little bit about her career with Achilles Pharmaceutical and her jump from the postdoc in academia to industry and how she decided to make these decisions, etc. So thank you, everybody, and welcome.
Hi from me as well. I'm Fenia. It's my pleasure to be here today, and I hope that you'll find what I have to say interesting and helpful. So I just need a second to share my screen. If there are any issues throughout, just let me know. So yeah, as Eleni said, I'm Fenia Sapountzi, and I currently work for a company called Achilles Therapeutics, and they are based in London. So today I'm just going to talk to you a bit about working in academia versus in industry. There we go. So the outline of this presentation is going to cover a bit about myself, the reasons why I left academia, the key differences between industry and academia, and how you could potentially decide whether a career in industry is for you. And if you do decide that that is the case, where to potentially start. Okay. So, as I said, I'm a senior scientist within the Research and Development Department of Achilles Therapeutics. And the way that I started, so I'm initially, I am from Athens, Greece, and I moved to Glasgow in Scotland to do my undergraduate degree in molecular and cell biology. And that's where I met Eleni, so that was in 2008. Then I moved to Finland to do my master's degree at the University of Tampere. And then I moved back to the UK in Edinburgh, where I did my PhD, and I studied cancer metabolism. So after spending so many years in Scotland, I was really, really missing the sun. So I thought, where is a place that combines the sun and good science? And that was California. So I moved to California for a year, and I did a postdoc there at a hospital called City of Hope. The focus is on translational medicine. So during my PhD, and especially during my postdoc in California, I knew that I wanted to transition into industry. And the jump wasn't really easy or very straightforward. So before I left California, I was applying for positions in small biotechs, and I kept getting knocked back. So it was really disheartening. So I thought, okay, if I can't get straight into industry, what I can do is do a postdoc that relates to the science that I want to go into. And I knew that I wanted to do immunotherapies for all kinds of cancer. So then I found a postdoc in London at University College London that focused on CAR T cells for blood cancers. And I thought, okay, this could be potentially a very good transition, and it will give me the key skills that I need in order to work in industry. And thankfully it did. And not only it gave me the skills that I needed, but it also allowed me to network a lot. And based on the networking that I created at UCL, but also at Edinburgh, I was able to get the senior scientist position in Achilles. And I think it was going to UCL was the best decision I made in order to transition into industry. So the reason I left academia, well, there are two main reasons really. I really enjoyed publishing, and I think it's quite cool to publish in the likes of Nature, Science, etc. But I found that it can rarely translate into the clinic. So it wasn't fulfilling me a lot. And another reason I left is because I didn't really enjoy working alone all the time in academia. And I would say most people working in academia will tell you that it can be quite lonely. So here are some of the key differences between academia and industry. I don't think it's an exhaustive list, but I think they're some of the most important differences, in my opinion, of course. The first one comes to interpersonal skills. I think they're exceptionally important when it comes to industry, but in academia, I wouldn't say it's so important. So when it comes to conflict resolution, effective communication, I'd say in industry is an absolute necessity. Another difference is flexibility, especially when it comes to working hours. In academia, I would say as long as you get your work done, it doesn't really matter what time you go in and what time you leave, as long as you do what you're supposed to do. Where in industry, the timetable tends to be a bit more structured. Let's say perhaps a 9 to 5. You won't always only work 8 hours, but those tend to be the business hours. Another difference is collaboration. So in industry, you will always have teams working together in order to achieve a shared company goal, as for example, bringing a product to market. Whereas in academia, you can work autonomously. And if you want to collaborate with somebody, you can choose to do that. Another difference is workplace culture. So I would say there are different types of pressure. In academia, you have this constant pressure that you need to publish and obtain funding. Whereas in industry, I'd say pressures are mostly deadline driven in order to meet business and company goals, such as, for example, dosing 10 patients by the end of the Q4 of 2021. Another difference is individual impact. I would say that in academia, you can make an individual impact and receive recognition. Whereas in industry, because you work as a single member on behalf of an organization, you won't necessarily receive individual recognition. And finally, I would say intellectual freedom is another big difference. So in academia, you typically can set your own research priorities, but you also need to worry about funding your own projects. Whereas in industry, you have typically somebody else, the scientific advisory, for example, setting your research goals. And at the same time, they make sure to secure your funding. So in order to decide whether academia or industry is right for you, I would say, and again, this is not an exhaustive list, but I think these are important things to ask yourself. So first of all, determine your priorities. What is it that matters the most to you? Is it the salary? Is it an intellectual freedom? Is it flexibility? The other thing is that you should think about how you like spending your time, like your day to day. Do you enjoy publishing, interacting, writing grants? Another thing is that you should consider is knowing what your strengths are. So under which conditions you thrive. Then of course, you need to factor in your personality. Do you like working independently or as part of a team? Do you enjoy individual success or team success? And while it's important to think long-term, you can absolutely keep your options open because your decisions don't need to be final. So if, for example, you transition from academia to industry, you can absolutely go back into academia. And lastly, I think at the end, what's the most important thing is to be true to yourself. So you should pursue the thing that makes you the happiest and that you're the most passionate about. So if you do decide you want to work in industry, it can be quite overwhelming when it comes to the beginning. And as I mentioned earlier, I definitely got knocked back a lot. And it was really disheartening. And I thought, you know what, maybe this is just not the thing for me and it's just not going to happen. But I'm glad I stuck through with it, because I think for me, it was the best decision I made. So if you do want to start and you do keep getting rejected, take a step back. And first of all, identify the key technical and soft skills that are required, and work towards acquiring them. So for example, as I mentioned, for me in particular, because I couldn't get into industry directly straight away, I found a postdoc and I did a postdoc in a highly relevant field. And there are also many, many positions, whether it's a postdoc, PhD, or just jobs that have collaborations between universities and industry, whether that's a biotech company or a more established company. And I do want to take a second, if there's enough time later, to just show you an example of this. The next thing is that you should prepare your CV in industry style. And there are a lot of differences between an academic CV and an industry CV. And the same applies for cover letters. So there's a lot of information available online. I'm mentioning here the cheekyscientist.com because they have a ton of content. Most of it is free. And I personally found it extremely helpful and very eye-opening. Another thing, speak to recruiters. I think many people will have a love-hate relationship with recruiters. I think it is worth speaking to them because it will have a pool of positions that may be available to them, but may not be available publicly. And I think if you pay a recruiter, an agency, you might be able to get a bit more out of them. Then seek out industry contacts. Networking is absolutely essential, and it absolutely helped me as well when I was trying to get into industry. So you can use LinkedIn or conferences or anything else. And on LinkedIn, if, for example, you identify a company that you're interested in, you can contact somebody from the company and ask if they have 5 minutes to talk about the company, and you asking them questions. And most of those people will be more than happy to help. Once you identify companies in your field that you'd like to work for, you can just email them with your CV and express that you're interested. And even if they don't have any positions available at the time, if they have your CV on file, at some point, maybe something will pop up that fits your skills. And finally, just because you don't meet all the job criteria doesn't mean that you shouldn't apply. And I would say, and I have found this personally, I would say that women especially don't tend to apply for positions if they don't meet all of the criteria. And I did this for so long, and I'm glad that I stopped thinking that way. Here is my LinkedIn. It's Thea Panagopoulou. Please contact me and add me for whatever you want. So I just want to take a second to show you an example. So what I was talking about earlier. So this is the role summary that I applied for and I ended up getting. So what I have done here is that I highlighted the key skills that they needed. And for example, they needed somebody in immunology that can do multicolor flow cytometry, molecular biology, cell culture, mouse models. They also needed someone that can effectively communicate. Someone with a PhD in immunology, T-cell assays, blah, 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 functional stuff. Again, something that seemed to be very important for them because they mentioned it twice in their job advert is having exceptional communication skills, problem solving, being able to meet timelines, being flexible, and managing current multiple projects at the same time. So the ones that I have highlighted here, I knew are the ones that I need to make sure that I mention in my CV and that I mention in my cover letter using effective examples. So what they want to see is not an endless list of everything you've ever done. They want to see everything that you know that is absolutely relevant to the position itself. So that is all from me. I have a couple minutes spare, and I hope you found that interesting. Well, helpful.
Thank you so much, Tano. So before we go into our next speaker, I just want to say that you touched on a topic that here in our symposium, while organizing it, we found it as a challenge as well. As you know, we're giving away some awards at the end to celebrate achievements and accomplishments of some of the younger women in science or technology. And believe it or not, although we were when we advertised the awards, we said that, you know, you have to be maximum 10 years after your bachelor's, and we were looking for exceptional women, but we didn't have very strict criteria. We just wanted to see what everybody has done so far. And we had very few applications in the beginning. People, younger women were reaching out to us and they were saying, but I'm not exceptional enough, but you know, I don't think I qualify to apply, and telling them that you don't need to check every single box and apply anyway. As I said in my speech in the introduction, it was one of the biggest things we had to do in the organization of this symposium. And I'm actually very happy we did it, and we got quite a few at the end, and everything worked out great. So we'll talk, I hope we'll talk more about it in the panel after the interesting talks. Our next speaker is from UMass Medical School in near Boston, Maroula Tsagkari. She's an MD, PhD. As I like to say, it's one of those people where they just wanted to do both. So the stage is yours, Maroula.
Thank you very much. Second. I'm sharing my screen, I think. Thank you so much, Ellen, for the very kind introduction, and congratulations to the organizers. This has been a wonderful two-day symposium. I also heard a lot of interesting things in fields that I didn't even know about. So today I'm going to take you to a different path from the one that we have discussed so far, and it's actually the path that brought me from Crete, where I come from, Greece, to Massachusetts, United States. And this is the physician scientist path. And some of the people, some of the audience might already be in the beginning of this path or in the middle, but I hope this will be useful. So in today's discussion, I'm planning to talk to you about how I set my professional goals, what was the mentality, how I was thinking, how has been my academic career so far. And in this session, I'm going to give you couple of resources, some programs that were very useful for me. Then I'm gonna very briefly talk to you about my research work, and very briefly about my future plans. And my goal in this brief talk is to inspire those who are in the beginning of a similar track but don't really know what they're going to do, offer ideas, to motivate some that might feel stuck, provide certain resources that for me, like I said, have been very useful, and definitely keep in touch if somebody would like feedback or to discuss or some piece of advice in this journey that I'm still on the way as well. So I've always wanted to become a physician, and that's not the case for most of the people, but I knew it from a very early stage, despite that I come from a family that is very polytechnical school oriented. And why was that? Because I was very curious about how the human body functions, why we're born, why we die, how life is maintained, and all of that. And then I would like to have a profession that really has an impact on the lives of people. And there are many, many jobs that do that, of course, but being a physician is definitely one of them. And lastly, I was very fascinated with science. And apart from these things, I was very into maths and problem solving. And I had the good luck to be exposed to doing experiments in chemistry or science very early. And of course, like in this journey, you need to be in the mood to spend some time in academia, because holding an MD degree and a PhD degree means at least a decade and over in an academic environment. And because of all these reasons, initially I was saying I want to become a researcher, doctor, and then I realized in the middle of high school that there's actually a term for this, and it's called physician scientist. And it's actually the physicians who play a really critical role in transforming what is done in basic research to actually clinical application. And this role can be in an academic environment, and it can also be in industry. So how did I start? I start with going to the med school, of course, and I went to the University of Crete Medical School, which gave me really good exposure to conferences and workshops, presentations, and it was really good. And I would really advise people who are during their undergrad studies to do be exposed in original research as much as they can, if they're interested, of course. So in University of Crete Medical School, you can basically shadow or even actively participate in the research of many different laboratories. And this is definitely a really good experience. And then one thing that was very beneficial was the exchange programs. And there are the usual exchange programs that are in most universities in Greece and Europe, but I'm going to focus on the Boston exchange program here. That was very unique, that is unique of the University of Crete Medical School. So, 1 second. So this program started back in 2001 and is based on the affiliation between the University of Crete Medical School and the Boston University School of Medicine. And it started by a really great mentor who's called Vasilis Zanis, and started this whole program. Students can go on a lab rotation on their 3rd year or clinical elective on their 6th year, and the selection is based on academic performance. So far, here's some facts. In these 20 years, 230 Greek students have come to Boston in the context of this program. A comparable number of American students have gone to Crete in the same program, and the early alumni of this program now pursue careers in academia and industry. And there is also an alumni association of this exchange program, which is a really good networking opportunity. So I went in 2013 in BU for a lab internship, as you see here, and in 2016 for a clinical elective in Hemong, Boston Medical Center. And I think these exchange programs are very, one can benefit a lot because they expose you to a foreign country like the United States. Of course, there are many countries like this that are known for the advanced biomedical research and education. You can see a different approach in the healthcare with the pros and the cons. You're exposed to a very diverse environment in and out of academia. And the most important, it's a very short term with a return ticket, safe trial to see if you match in such a path. So the second thing that happened after I graduated, which is something that to anyone who in Greece who wants to pursue this journey, I strongly recommend, is the graduate program Molecular Basis of Human Disease, again in Crete in the medical school. And this combines graduates of basic science like biology, chemistry, and also MD graduates. And the goal is to bridge the gap between basic science and the physicians. There is a very strong collaboration network in this program with scientists of international recognition in academia and industry, and you have the opportunity to pursue your thesis in Crete, in Greece, or abroad, which is what I did. I went abroad. I'm going to talk about this in a couple of slides. Another thing that was very important for me, and it was a life-changing experience, was the WHBA summer school in Neo Lomani. It happens every year, and I could summarize my experience in these 4 words: inspiration, knowledge, mentorship, and networking. So I ended up coming at UMass Medical School and joining the Michael Czech Laboratory to pursue my master's thesis and my PhD thesis. And here's where I want to say that to follow a physician-scientist path, you need to spend a lot of years in academia, actually. And to briefly tell you what I've been doing, basically I'm working on type 2 diabetes, and I'm not gonna talk a lot about this, but we know now a tissue that is very important for type 2 diabetes is the adipose tissue. And we know there is 2 types of adipose tissue: the white, which is the adipose tissue we mostly have. It stores energy, and the brown adipose tissue, unfortunately, we don't have a lot. It's very beneficial. It spends energy towards thermogenesis. And for my project, we developed and optimized a model whereby we can use CRISPR-Cas9 gene editing to convert white adipocytes into brown. And this we showed that can be applied in therapeutics by isolating initially from mice, essentially from humans, white adipose tissue, using CRISPR to convert it into brown, and then by implanting these converted adipocytes back into a diabetic individual, we can correct the diabetes pathophysiology. And you can read more in these publications that I mentioned here. And very recently, we have been very excited to transfer this into human adipocytes, actually, in collaboration with the Corvera group at UMass too. So why United States? So in my opinion, United States, as a very early discovered, provide an excellent infrastructure and wonderful funding opportunities to do biomedical research. You can establish great networking in the United States, just like Nanou said. It's very important for any future step. For a physician-scientist path, it provides really good residency and fellowship training with great support to do also research, either clinical or more basic translational. There is a great supportive system for physician-scientists, essentially with protected time to also do research on the side of the patient care. And one thing that I loved is United States is a very diverse environment. There is a lot of cultures, countries of origin, diversity in any level that you can think of. So my future plans are to do residency and fellowship and essentially seek a physician-scientist position, and holding an MD and then a PhD is the most important steps one can do towards this pathway. And I'm going to close with some piece of advice, which also matches Nanou's presentation. Once you know, usually talk about the things that we have done, and we very rarely talk about the things that we seeked and we got rejected from. And I think it's very important to know that once we know where we want to reach, there is multiple ways to reach. There can be dead ends on the way, but you see how, especially in this symposium, how people from different backgrounds, they ended up doing similar research and then again split into different directions. So if you want academia, if you want industry, there are multiple ways to reach in the position you want to reach. And here is my contact information, and I would be very happy to stay in touch with anyone who thinks can get useful advice or feedback, or I can help somehow. Thank you very much.
Thank you very much, Emanuela. This is a very difficult path. It's a very difficult path, and it's a lot of work, I'm sure. Some of the most successful principal investigators I've met during my 12, 15 years in academia so far have been MD, PhD holders. And that's exactly because, as Emanuela said, they can bridge that gap between clinical translation, research, and medicine. And to me, it's just extremely exciting. Okay, so our next speaker, we're gonna go, so far we've been in England, London, we've been in USA, Boston, and now we're gonna go to Zurich. Mariana Rapsomaniki, she's a research scientist at IBM in the research lab in Zurich. Her area of expertise is computational biology, and her research interests involve mainly understanding the spatiotemporal tumor heterogeneity using a combination of single cell analysis and other approaches. Mariana, the stage is yours. You need to unmute.
Okay, great. So I hope you can hear me now and you can also see my slides. Thanks a lot for the introduction. Thanks so much for the invitation, but mostly thank you for the amazing work that you've done. I think it's been really, 3 amazing days. I managed to follow most of the talks and I've learned so many things from really great lineup of speakers, so thanks. I'm gonna talk a little bit about my personal career advice from my experience in both academia and industry, as Ellen just said. Let's just quickly start by saying a few things that I'm going to talk about, which essentially, when Ellen contacted us about this session, I was really thinking, what are like the 3 main things I want to communicate to people, and what are the things that I wish someone had told me in the past when I was younger, but also because I'm a little bit involved in mentoring as well, what are the most common questions I get from people, So these are like the things that I selected. Also already, like Theano and Emanuela talked a lot about the second point, what's the biggest difference between academia and industry. But also I think 2 main important questions that I very often get is, how do you choose your path? How do you find your way, right? And lastly, how do you combine career with family? So let's start with the first question, how do you find your path? And let me tell you a little bit about my path. So I was born in Corfu, one of the most, beautiful islands of Greece, which is, not only beautiful, but also a very, very small place, right? So this is very, very important because growing up in Corfu, of course, education is very important, like secondary education, but then you're not really exposed to, there's no university. Actually, there is a university, but it's a really small university with very specific studies, like musical studies, history, translation, and so on. And I wasn't really so much exposed to an academic environment, not also from my family that didn't have an academic background. And I think this was really a huge challenge when I was growing up to understand, what I want to study. And that's why the work that you guys are doing is also so important, right? And impactful. So when I was finishing high school, I was really good in math in school. And I also had a math teacher that was, I would say, like a mentor or a role model. I really loved math because of him. And when I was finishing, one of the topics that I really liked was biology. I was really fascinated by biology, like Emanuela said before, how the human body works, how do our cells work. It sounded really fascinating. But however, when I was finishing, because my grades were really high, everyone was telling me, are you crazy? You're gonna study biology. No way, you will ruin your life, and I mean, literally everyone, teachers, not so much my parents, they didn't intervene so much, but I think my high school teachers, for example, they thought, it's unbelievable. No, you should go for engineering, electrical engineering, or, some other engineering discipline, let's say. So I remember I had the thought that, okay, this is something that I love, biology is something that I love. But then, it's since everyone is telling me it's a very stupid thing to choose, I shouldn't do it because it cannot be that everyone is wrong and I am right? So I opted for engineering indeed. And I went into the Department of Computer Engineering, which was an interesting couple of years. I have to say, I hated it the first 3 years. I didn't like it. I considered dropping. My grades were also not so good. But then, you know, around like when we're close to finishing the studies and we are choosing a topic like for a diploma thesis, I saw this topic like bioinformatics. And I thought, okay, now that's something that, you know, that sounds very interesting for me. So I learned more about that and I was really fascinated. And I did like my diploma thesis in this topic. I worked with a really talented postdoc that was coincidentally the first female that I saw in an all-male faculty, the first female that I saw doing research while also having kids. She had 3 kids. And it was really remarkable for me to be able to see this example of her, right? And this is like a pattern that I will mention from time to time. So I was really into that. And then, you know, this made me do a master's in bioinformatics in the same university because I wanted to learn more about it. So this was a really nice program. In the first year, we did only, so it was like split. Half of the people had a life science background and the other half had an engineering or mathematics background. For us, we did a lot of classes in like the medical school or the biology department and so on to familiarize ourselves with the basics of like how our cells work, etc. And the other half did a little of mathematics, programming, etc. to catch up. And then in the second year, we would all like merge and start working together. And so it was really, really interesting to see the other side, you know, how, you know, like also even like teaching, I think in biology and medicine is like very, very different how it's organized. So this was really eye-opening. And then it was really when I knew this is what I want to do in my life. Like, this is like my mission. I want to learn everything about it. I want to do research in that. And I was really, how can I say, driven to push forward. So during my master's, one of our professors from the medical school was really, again, one of the people that I idolized. I really loved how she was teaching. Her way with the students was really amazing. Coincidentally, also a woman and also a mom, right? And I thought, okay, like I want to be like her. You know, I really admired her. And when I was finishing the studies, she helped me a lot with mentoring, how to choose what to do and so on. And it so happened also that there was a position opening in her lab to work on a systems biology project together in collaboration with a lab at ETH in Zurich. So she told me, you know, there's this opportunity, would you be interested and so on? And immediately, of course, it was like for me, one great opportunity. And one thing that made it also possible to happen is that around the same time, I saw an ad through my university about a Swiss government scholarship. So this is a scholarship that the Swiss government gives to people from all countries, not just Greece. You apply through your local Swiss embassy. So you actually, if you're in Greece, you have to go to the Swiss embassy in Athens and you have to interview and so on. And I did that. And of course, when I applied, I was like, there is no way I will get it, you know. This relates to what people have said throughout these 3 days, you know, imposter syndrome, feeling we don't deserve it, we shouldn't apply, and so on. But I did apply either way to get the experience. And it was a great shock when I received the email that said that I actually got it. And I had my own funding to go to Zurich and study for my PhD. So this was really a remarkable opportunity to just have this opportunity through the scholarship. So, okay, then when I was finishing my PhD, I was already in Switzerland. I spent half of my time as a PhD student at ETH and half in a medical school in Patras in Greece. And when I was finishing, I was looking for something in Zurich. I was also married, you know, I got married exactly when I was some months before I defended my thesis and so on. So, and my husband was here. So it made also more sense for me from a family perspective to look for something in Switzerland. And I started looking around and then I saw this. I wasn't looking for a job in industry. I was looking for a postdoc, but, you know, I was looking in nature jobs with specific keywords that fit the projects that I wanted to work on. And then I found this ad that was at IBM Research. And I thought, oh, okay. I mean, it's industry, but the ad is like incredibly, you know, interesting. It's exactly what I want to be doing in my next career path. So, I mean, I will apply. So I applied, I interviewed, I went and I met the people and I really liked it. I mean, I like the environment, I like the people, I like the topic. For me, the topic was the most important thing. I like the fact that it was taking the things that I had done in my PhD to a more, you know, applied manner. So I would have to work with actual data from actual patients and so on in the context of cancer. So, and I've been with IBM since 2015. And since 2017, I've actually been working as a research scientist, so after my postdoc. So very briefly, what I'm doing without going into a lot of science is in the context of computational systems biology, where what we do is that we work a lot with big data in the context of biology coming from different experiments and so on. In my case, also a lot of single cell data that is like really revolutionizing cancer biology right now. We model this data with different approaches, like deep learning, machine learning, mathematical models, and so on, and all in the context of cancer heterogeneity. So understanding what are the molecular mechanisms, molecular drivers of tumorigenesis, understanding and modeling heterogeneity with the ultimate goal to contribute to what we call personalized medicine, right? So better stratify the patients, pick better targeted treatments, and so on. So that's more or less like my area where I work on. So now when people ask me how you find your scientific path, I always talk about my example, because actually my example is a classic example of a non-linear career path. I didn't like study one thing and then from that thing, I didn't take like all the expected decisions to move forward. I really switched, and this switching was the best decision that I made. I think I would have been extremely unhappy if I hadn't done that and I was still working as an engineer. It wouldn't be something that I would like. So don't think that people or people that are successful in their careers, don't think that they always had it figured out. It's very often the case that they didn't have it figured out, that they had to make drastic decisions, even dropping out of things, changing, and so on. One of my very good friends and a good colleague of mine, we did our PhDs in the same lab. He was doing his master's and I was doing my PhD. He actually started studying civil engineering, and he dropped in the third year of civil engineering to study biology, right? And then he was extremely successful as a biologist. He did his PhD in Columbia. Really amazing publications came out from his PhD, Science and Nature papers, and now he's working as a scientist. So doesn't mean that successful people always have it figured out. So it's good to question yourself. If you feel you're at the dead end sometimes, just make the switch. I mean, it can be scary, but maybe it's what you need to do in your life. The second thing is that, also relating to the previous one, you can always find a way to combine the things that you love. It's like today, there are no boundaries in science. If I tell you in our group at IBM how many different backgrounds people have, we don't have, we have biologists, physicists, engineers, mathematicians. It's really remarkable. And one of like our top actually software engineers is a biologist. Did not even study engineering, but he was a super motivated person and this is what he liked. So it's very, very easy now to find a way to combine, I don't know, like power systems with machine learning or whatever. I mean, you've heard all the talks these days, you saw some examples maybe, but there are really no limits, I think. And the way to do that, to understand, how maybe you can do it and you can find your path, is talk to people, as many people as you can, get informed, network, find mentors. Great initiative is Greek Women in STEM as well, that you can find really amazing mentors there. Ask around. Don't feel that you are, bugging people if you send them an email for some advice. You're actually not. They would most of the times be very, very willing to help you, because most of these people have been in your position. Always remember that. And if they don't help you, fine, move on. Just, maybe they're just too busy. Don't think that you bothered them or anything. And then don't settle. If, you want to do something, even if you have some rejections, initial rejections, just keep on pushing. You will make it through if you're determined, and this is what you want to do. Always, however, bear in mind, and many people said that already, it's a really hard work. If you are a researcher, it's 99% of the times you fail, and one time you are successful, and then, when you're successful, you don't even have time to feel good about it because you have to keep on pushing. So be very persistent and don't get discouraged by failures. It's, I think, always about, paper rejections, grant rejections, and so on. This is just part of the business, and you just have to keep on pushing and learn from the experiences. So moving to the second topic, I'm not going to stay so much on that because we already heard really great advice from both Eno and Emanuela, but I think I will just tell you a few things about where I work now. So where I work is industry, but is research. So it's the research branch of IBM that I guess all of you know. It's, like a big giant of technology. And it has a lot of research labs worldwide. The Zurich one where I work is the first one that was founded outside of the US. So it's the oldest one in Europe and worldwide, apart from the US ones. This is how our campus looks like. It's a really beautiful place. I really missed it during the pandemic, but now we get to go at least once in a while. So the environment is a research environment, but an industrial research environment. So keep this in mind, right? But okay, what are like the main differences? And as I said, a lot of things were already mentioned. I will tell you from my perspective. I don't want to generalize that this is, everywhere in industry, it's like this. I think the first big thing that I had to get used to is the following. You cannot just go around and share your code and your data with everyone, because it might be you're working on a project with a client, for example, and it's protected, there's IP, right? So you have to be a little bit aware about this thing. And, if you cannot live with that because you want to be able to talk about everything with everyone, maybe an industrial environment would not be ideal for you, right? A second topic is that in academia, you choose your topic, which is really nice because you have freedom, but you also have to fund it. Like the older you get, you have to find money for that, right? Which means that if you have an amazing idea that's really incredible and you're after the postdoc level, there's no way to get it funded, you cannot actually work on that, right? So this is not, free is a nice thing, but it also has to be realistic. In industry, on the other hand, if your research fits the agenda, you can do it, right? It has to fit the agenda, but you don't necessarily need to strive for funding in this context, let's say. Another very important thing already mentioned, you're judged by your publications, but in industry, you're more judged by your performance. So there are other things that are very, very important. I would say also another very important aspect, and what I didn't like about academia is the instability of the work. So I didn't want to move after I came to Switzerland. I wanted to stay here. I didn't want to make a big jump, look for a postdoc somewhere else and so on. And I think from this perspective, industry is a little bit better. Your job, if you get a permanent position, you're more stable. You don't have to strive for tenure with all, that this concerns. And then maybe the pay is depending a lot on the topic, but it tends to be much better in industry, like your payment, your salary or your bonuses and so on. In industry, you manage your time. This was already mentioned before on your own, but I think most of the time you just end up working weekends and overtime. In industry, there's more focus on work-life balance. And finally, I think the hierarchies are a little bit different also in industry. There's more teamwork. Also, this was mentioned before. So now I'll briefly talk a little bit about my another question I get very often, which is how to combine career with family life. And just I don't want to bore you with statistics, but some very troubling statistics about the wage gap that we know that it's a big topic. It's been really discussed in the last days by other speakers as well. In Greece, actually, we're not doing that bad. It's okay in comparison to other countries, okay. But, like Switzerland, where I am, is actually pretty high, right? And I think for me, the most troubling statistic is the fact that the wage gap is not actually a wage gap, is a parenting penalty that is affecting disproportionately women. So you can see these are results from Denmark of all places. So a place that we think, that there's much more equality, not so much sexism in the society and so on. But you see, like how earnings affect men with or without children, and how earnings evolve for women with or without children. So it's really that the wage gap is a parenting penalty that is disproportionately affecting women. And this is also true in STEM, where we see that a lot of mothers actually leave research after they have their first child. They leave workforce entirely. They choose to stay at home. And this is absolutely a valid choice if this is what you want to do. So if you decide that for your family, the best choice is that you want to be a stay-at-home mom, by all means, do it. But don't do it because you have no other option. Don't do it because you feel pressure from the society that this is like the only way, right? Don't do it for the wrong reasons, I want to say. So for me in 2019, I had the pleasure to welcome this little guy in our family. And the past almost 3 years, we've been sharing that together during a pandemic, which has been extremely challenging, to say the least, but also very rewarding. So I think it made me reevaluate a lot of things. about my life in general, and I will try to share some lessons that I learned throughout these years. I think the first and most important thing is educate yourself, right? What are the laws in your country? What are the rules in your company? Talk to your HR. Don't settle for situations where you're actually pushed to take decisions that are even against the law, right? So just educate yourself, know your rights. Very, very fundamental thing. The second thing is what I mentioned before. You are the person that can make the best decisions. Maybe you and your partner together, right? But do it on a prepared basis, on an educated basis. Don't feel societal pressure to do something, because then you would be mom shamed if you are a working mom or whatever. And then, of course, they always say it takes a village to raise a child. And this is really the case if you want to have a career. So make your own village, find people that can help you. It can be grandparents, it can be nannies, it can be, daycare and so on. So prepare a little bit your village. Then don't make assumptions when it comes to work. For example, it's like very often the case that you assume people will be mad if you have to leave work early, but it's actually no, just explain it to them that you need to pick up your child, explain your limitations, let's say, and communicate that. Talk to colleagues about, meetings, deadlines. If there's a deadline, let them know you cannot work around the clock like maybe they do. So they need to have that, to take that into consideration, and work efficiently and don't distract yourself with things. So this is something I really learned, like I have 9 to 5 to work. And in this 9 to 5, I need to do the best that I can. And then when you are not working, I strive with that every day, but try to spend quality time, not only with your family, but with yourself, because it's really like a marathon. Take even 30 minutes off for yourself, whatever you like to do, self-care, extremely important. And I think I leave you with this quote that I find really inspiring from one leading scientist in immunology that actually said, are you pregnant and you want to go on an interview, go pregnant on that interview. If they reject you because you're pregnant, you don't want to work for these people, right? So walk away if you see these toxic environments. I think also another speaker mentioned that before, but really walk away if this is the situation. So I think that's all from me. Thank you so much again. And you can always contact me.
Thank you, Mariana. Thank you. That was actually eye-opening, because I know that there's quite a few of us that they're thinking, okay, I might really want to be a mom, but how is that going to affect the career that I've been building for 10 years? Or, how can I do it? So we have some great questions, but before we go ahead and start talking about questions and discussion and all those wonderful comments we're getting on the Q&A from all of you, I would like to, and you can actually hear my fur child on the background. I would actually like to introduce our panel. We have 3 amazing ladies. They are handpicked for specific reasons. We have Dr. Iro Koliakou. Iro is the STEM coordinator of Anatolia College, and she's coordinating the European projects related to all the STEM education. She's also a teacher in physics, and she's also a teacher in the master's program in the medical school of Thessaloniki. And then the reason why I reached out to Iro is because pretty much advice is what she does for a living. Helping all the younger kids with all the questions that maybe they don't know how to answer, or they don't have the material to answer, and guiding future scientists. Our next panelist, Iro is in Athens, by the way. Our next panelist is Maroula Tsagkari. She's an academic coach, and she likes to help young people to realize their potential. She's in the University of Oxford, and her field is digital culture with an emphasis on online musical communities. She's also done a stint in academia as a postdoctoral research. The reason why I wanted Maroula on the panel and I reached out to her is exactly because she does a very similar thing to Iro, but not for high school students, but university students. So I wanted to have a panel where we have all the levels covered. And then least but not last, we have Katerina Ronga, and she's a principal in the Risk Advisory Department of Deloitte Greece for the last 2 years. Katerina holds more than 18 years of professional experience in a range of areas. It's mostly dashboards, data analytics, and more. And she's very experienced in everything industry related. So as you can see, we try to have a complete panel with people that they can cover all of your comments or questions. And finally, we have Martha Vardaki from the University of Ioannina. The reason why I wanted Martha to join us, she wasn't on the original panel, but I asked her to join us. Martha has been in, I believe, 2 sessions so far. Martha is, like myself, a career academic. So we've heard from Emanuela about the MD PhD route. We've heard about Theano, why for her it worked great to jump from academia to industry. We heard about Mariana doing industry research, but I wanted to have a voice to speak about academia, which is not going to be my voice, because it's not about you guys listening to my voice. I want everybody else to be heard. So with that, I want to read a couple of comments and questions from the Q&A that we've received. Some of the questions are general for everybody, so everybody just feel free, take a question. Some of them are a little bit more targeted. So the first question, I believe, is for Mariana. Katerina Bridjolaki, she says she totally agrees with you, and it takes a lot to figure out the path you want to follow. I was so close to dropping out at several points throughout my academic path. Katerina, a lot of us feel very much the same, and she wants to know if there was a pivot moment that made you choose your current path, and what are some of the difficulties you have faced as a woman in industry. And of course, after Mariana gives us an answer, please feel free to chip in, and we all have experiences that we can share in a helpful way.
So great question. I think for me, it was really when I was trying to pick a diploma thesis project, and I saw the ad, bioinformatics diploma thesis, and the lab that was hosting this. The students was having like a meet and greet type of day. So we showed up and they were just explaining what the topics are about. And it was the first time I was hearing, bioinformatics as a word. But the most important thing, and why I always say representation really matters, is that the person that was talking about these projects, as I said before, was literally the first woman. I don't know how can I explain that. Like where I studied, the faculty was all male. Not even one woman, really. And this makes you feel you don't belong. Even if you're good, it really makes you feel you cannot see yourself doing this thing. And it's really implicit. It's really, a tricky situation, because it's like in your brain rooted without you even realizing that. So then I went there, and she was literally like holding a baby and, presenting these topics. And I was saying, wow, I mean, not only can you be a woman and do research, but you can also have a child, the stereotype of like career woman doesn't like children and doesn't want to have a family and so on was so like stupid and fake and perpetuated by culture and cinema and all these like stupid stereotypes. And I think this was for me, like when I understood that it's all like really stupid the way that I had it in my mind. And also so this very important, like how I made the choice. Now about difficulties that I've faced as a woman in industry, I don't want to sound like I'm advertising my current employer, but it's actually the conditions are extremely good for females. There are a lot of initiatives. We do a lot of internal trainings, actually, which is another thing that doesn't happen in academia. We do so much training about how to fight implicit bias in the workplace that I think we've all gotten better in that department. So I've never had to face a difficulty that was specific because I am a woman. I mean, of course, there are difficulties, right? But nothing, and even since, I became a mom, I think I had it so much different in my head. I was making the assumptions that I'm gonna face difficulties. The first time I went to my manager when I was pregnant and I wanted to talk to her about, maternity leave and so on, I thought, I'm gonna ask for a year of maternity leave so that she tells me, no, it's too much. I give you 8 months and then, we're happy with 8 months or something. And I went and she told me, how long would you like your maternity leave to be? And I said 1 year. And she said, fine. And I was like, okay, you know. So sometimes you make assumptions that are really stupid and not true, because we have this idea in our heads that like being a mom is a disability, you know, and you need to apologize because you want to bring a human in the world, right? So it's really not like this. In good places, good employers are not like this, and try to find these employers. It's very, very important.
Thank you, Mariana. Thank you. Yeah, I guess a lot of people would think that way. Is there anybody who would like to add or comment?
Yeah, Helen, adding on Mariana, actually, and what you already have referred to, it's a little bit difficult to believe that the society, in general, the cultural thing, is actually requesting from you a balance or something. You are starting feeling crazy. What am I doing now with my family? Should I go and have a family, or this will leave my career, you know, and this will delay, let's say, our career path. So it's very, very important to believe in ourselves, to ensure that we have come here in order to make an impact that matters. This is our dream, and everything, if we want to balance them, we can achieve them. You, all of you, and we as a women were real examples of people that can do everything together and in parallel as well, because this is a skill for women. And based on the industry part, I can see it also in our colleagues. We are women, we can differentiate due to the fact that we can do a lot of things in parallel and with great quality. So I would say that just everyone to live their dream and their and what they want to do, and just make an impact that they want, because that's why they're here.
Live the dream. I totally agree. I absolutely agree. I'm going to turn it around a little bit. We had a question for Iro. I just want to say I'm so happy I read this comment. So we have a high school student. I'm extremely happy that younger people are interested in a symposium like this, and they care and they want to learn and be helped from other people's experience. So yes, awesome. So I'm a high school student and I want to combine mathematics and physics. Is this possible? And where can I work? Everyone says to me that if I graduate, and the if is actually capitalized, the mathematics department, I will probably end up a teacher, which I don't want to become. First of all, before I give you the floor, you will graduate because you're going to put the work in. Don't listen to anybody. And at the end of the day, you're not going to end up doing anything you don't want to do, again, if you put the work in. I'm sorry, the floor is yours.
So thank you, Ellen. So, okay, mathematics and physics, actually the physics department, like half or almost half courses are mathematics. So we can't do without mathematics. It's everywhere. As Mariana said, she loved mathematics. She found bioinformatics, so mathematics with biology. So mathematics can be combined with everything. The problem is that maybe the student is referring to like the Greek university, and that's something that a lot of people say, that mathematics department, it's really difficult. So you need to put the work in. And if I would give an advice, you would need to early on find what you want to do after you graduate, because both physics and mathematics, they're like really vast fields. You have a lot of things you can do after that. And if you find your focus and the thing that you're passionate about, the thing that I thought Thano mentioned, it, you need to be passionate about something. If you find your passion and then like focus on that and put in the work, you can achieve anything. Work, it could be either in industry or academia, and we heard like mathematics it's everywhere. You can go to bioinformatics, you can do engineering. I started from physics, I went to biomedical engineering. I did a PhD in regenerative medicine, and all of that started from physics. So actually you can do anything. And Ellen, it's really wonderful that high school students are interested in this. So that's the reason why I do what I do. I have a lot of students coming to my office ecstatic about all of this and about wanting to learn about what actual researchers do and what they can do in the future. So thank you very much for this.
Maybe I can add to what you just said. Can you actually hear me?
You can
Is that
you
better
speak a
now?
little, yeah, that's a little better. Can you speak a little closer to the microphone? Thank you.
Yeah, okay. So I'm actually a pharmacist by training, and then I went on and did a PhD in physics. So if I can go from pharmacy to physics, you can definitely go from mathematics to physics. Just because mathematics is such a big part of physics, as you all said before. And then also just keep in mind that if, for example, you go on and do a master's in physics, which can be essentially applied mathematics, right? Or a PhD, you get even more specialized. And that actually means that you don't need the whole physics background. And so I think it will be much easier for you to do that. But of course, as we go higher up in degrees like master's and PhD or postdoc, or even in industry, and as you get more specialized, you can actually combine more than one field at once. So that would be very convenient.
Thank you, Martha. Yes, I absolutely agree. Well, speaking about combining fields and all the things that you would need to have on your CV, and how can you use those keywords to actually make a compelling CV? I think we have a great question for Marilou as an advisor. The question is, would you elaborate more on keywords for your CV? And if you had in mind when you were looking out for a career, would you advise this approach for anyone still looking to find their path?
So keywords for a CV, can we take this apart a little bit so that I understand what this actually means?
So I think this is a combination between Theanos talk and your background. So, you know, when you have a job offer or when you're looking for a job and there's a job advertisement, I think the question is, how can you use the keywords in the job advertisement to tailor your CV accordingly? And, you know, I'm pretty sure there are resources for that, or there's people who can help you, because Theano, as he said to us, he did it, but how did he do it?
Okay, got you. I think it should be mentioned that every time you apply for a job, you need to redo your CV, and you need to make it relevant to whatever it is you're applying. So you could have a lot of experience doing many different things, but not all of that is going to be relevant to the position you want to go to. And you might think, oh, they might like me because I have done this and I have done that. Maybe. But recruiters are very busy people that they don't have a lot of time to go through everyone's applications in detail and really think about that and say, oh, look at that. Johnny has a background both in maths and physics, and they work a little bit in maths and then in physics. So you really need to go straight to the point. The other thing to mention is that when you send in an application, many companies will have an automated sorting system that actually is looking for keywords. So there's the filtering that needs to be done. The CV, I think most employers these days would expect you to upload to complete their digital application. So you kind of have to do it as they want it to be done. So it's no longer, you know, just upload a CV, job done. You do have to spend a lot of time, you know, applying for a job. I would say in regards to the job description is exactly what we saw earlier. You know, you take apart the key responsibilities and you're trying to find out how did you match these, and if it's something that is essential to a job, you really need to address that in that area, and just bring in some actual examples. I think that's what I would say. Yeah.
Thank you. Theno, you wanna, yeah.
If I could just add that a lot of companies, at least in the biotech sector, when it comes to interviews, etc., and also filtering the CVs, most of the time the first filter is going to be the HR department. So you need to think that you need to convince somebody who doesn't know your field, and then you'll get to the real assessors that are the scientists. So you need to convince the HR first department that your CV is good enough. I don't know how to say it, but it's good enough to go to the real hiring managers. So it's not just the technical skills that matter, but you need to make sure that you promote your soft skills, communication, management of projects, etc.
Yes, this is, oh, Katarina.
Sorry, Ellen. And adding to this that Theano and Maroula have already discussed, the CVs actually should be lean in order to be understandable from the HR departments and generally to get a grasp on this. And then I think that this is all that has to do is about character, about creativity, innovation on the interview, and generally, if you are yourself, it is okay. But the first part, yeah, is to be lean, as smart as you can. This is the key.
Yes, this is actually a very important point. I have been helping people with their CV and employability skills since 2009, and I remember when they were giving us advice, one of the very first things they said to us was, you need somehow to make your CV stand out. You need to, as Maroula said, all of the people who are going to look at your CV, they have a stack about this big, and somehow you need to stand out. I have to say, as everybody being a Greek person, we have very interesting last names. And that's actually something that makes us stand out. So, we got that going for us. All right, so the next question, again, something that makes me very happy, is from a male attendee. Kostas Athanasiou asked, what's the most significant challenge you're facing from male colleagues in your day-to-day business? I guess it's a pretty big question. I'm opening, the floor is open. You guys can.
I can start just by something just came to my mind. I think the most common thing that we encounter is like certain phrases or certain behavior which has been normalized. So I'm not sure how to explain that. Like a man can just turn around in a professional environment and say, oh, you're so pretty, and then you'll just try to divert and be more diplomatic, but you won't really be surprised because we listen to that stuff every day, like all around us, and we just think it's normal. That's what I meant by normalize. So I'm not sure if it's a challenge or not, but it should be.
It's hard for me to actually swallow the fact that at 2021 we're talking about, I'm sorry, somebody's hungry. We're talking about the fact that a woman, like being good looking, can be detrimental to your work. It happens and it's real. Do we have any other comments on that? I'm sure we have all faced.
Yeah, so I have to say something. In the physician path, on the way, even from the undergrad years, you will, I think any woman will encounter, not necessarily from male individuals, but from mentors, from the society, from colleagues, oh, think very well what specialty you want to follow, because I guess you want to have a family too. Be careful, for example, don't become a surgeon, don't become this, don't become that. Oh, you want to do PhD? Oh, but yeah, but you'll be 30. Don't you want to have a family as well? Like these things that it's, you know, these small things, and you don't really need to answer to those. Essentially, you will end up doing what you want to do, but they also seed a doubt inside of you sometimes, like, oh, maybe he's right. Can I do it? Can I really? So that is the biggest challenge, which is not something that you really have to reply to, but is a challenge to overcome inside of you in such an environment and in such advice, which maybe it's intended well, but we also see examples that yes, you can combine, you can be physician scientist and work in the clinic and do research and have a family, and really take good care of your children too. So I think that's a challenge to overcome inside of you, despite of this environment, do what you really want to do in spite of all these.
I guess I also have an example, and quite similar, and it is also something that I feel is normalized, and it's normalized with humor, which I think is ridiculous. So one of the professors during my PhD, when I wanted to speak to them about something, they're like, "Oh, hope you're not pregnant, are you?" And in my head, I was saying, "F you, if I want to be, I'll be." But and then he would always say, "You know, my wife had a really good career in science, and she published a cell paper, but then she decided to have her kids, and now, you know, she needs to be an admin assistant." So things like that, a lot of comments that are meant to be funny and humorous, I definitely have heard, I've personally experienced, and I think they're definitely absolutely ridiculous and extremely inappropriate.
Yes, Mariana, I know I just kind of stole your spot here. One thing I want to say is sharing those examples is something that will help us all. However, after we share all the you know, not bad is not a right word, but all the disheartening behavior and comments and challenges, I think it's going to be extremely useful for all the young women and men that they're listening to us to have a conversation about how can we start changing that this is happening, because clearly you can't turn around, as Theano said, and, you know, say something extremely inappropriate to your professor or your boss, or especially if in their thinking it's meant well, not maliciously, it's a joke. So how could we overcome those challenges and actually change the playing field? Mariana, I'm sorry, the stage is yours.
So it's exactly like you guys said, it's always as a joke, right? These remarks are always as a joke. And if you speak up, you cannot take a joke. What's wrong with you? Aren't you cool? Why don't you take the joke? You know, I was just joking. This is what they're going to say. If you speak up, you're definitely going to hear, why can't you just take a joke? No, I mean, we cannot take that joke anymore because this sets an example. And I think, okay, what can we do about that? I've heard these stories many times. When I was a student, I think I was telling you, Ellen, at a certain point, when I was a student in the engineering department, we were doing like, you know, a type of assessment, like a project. And then we went like for an oral exam with my colleagues. 2 of them were male and I was like the third person. And it was assumed I was the one that did the coffees just because I was a girl, you know? So it's like, there's always these assumptions. And then, you know, as you grow older, like they say you're pregnant and they assume you're gonna stop working, right? So it's not just men, because women can also be very sexist. I mean, sexism is a system. It's not that men are sexist, and also men can be allies, right? So I have great examples in my workplace that are really allies. And I remember also one case, we were having lunch and there was a male colleague around my age and my career level, and he made a very sexist joke over lunch that he used a sexist slur that I don't want to repeat, but it's a very common one. And I called him out, and in a very bad way, like I told him, I mean, it's really sexy joke and I don't appreciate you saying that. And he was a bit like surprised first, like that someone called him out. Then he said, I'm just joking. Then he stopped talking to me. And then a couple of days later, he came to me and he said, you know, you were right. You know, I thought about that. And then a month later, a very young student that was in that lunch, female, she came to me and she said, you know, when this thing happened, I really thought you're exaggerating. You're like, you know, why is she behaving like she was just joking? And then I realized how many times I've heard this joke and I've laughed, like, haha, politely smiled. And like, no, I mean, and I think the older you are, and if you are in a position that you can question this authority that is making the joke, do it by all means. I mean, if you're a student and your professor is saying that, of course, you cannot call him out, right? You cannot say, you know, what is this is like unacceptable behavior, although you should be able to do it. But if you are in an environment that is systematically perpetuating these beliefs for women and so on, find other ways to, you know, complain. Like in many universities, there are things that you can do if this is the case, and don't try to be pleasant. Don't try. This is like it's in our DNA. We always try to be pleasant, but don't try to be pleasant if this is unacceptable and wrong, because think of the younger people that are on the table, you know, and what example you're setting for these people.
And it is an institutionalized thing. And I think it's important to be able to discriminate. Just because someone is making a remark like that, that doesn't mean that they're a bad person. It just means that, yes, it is, sexism is very, very institutionalized. And I think it will take some time until we catch up with the age that we live in. And it's just a matter of, well, hopefully being patient and being able to explain to that person, as you said, that, well, what you said is not cool for this and this reason. And hopefully they will take a second to think about it, understand that they have been wrong, and perhaps perpetuate that to somebody else that has made another remark.
I was wondering if you guys find that is where the comments are coming from are mainly from older men. I'm just trying to assess how much hopeful we are for the new generation here.
I think in my case, they have come from older males, but I've definitely experienced a lot of sexism coming from females my age as well.
I see a lot of heads just nodding like this. I think one of, as Marta said, we should be hopeful for the new generations, and no, not because, you know, the older male, condescending male are going to be older, not because of that, but because I think nowadays we're educating the younger people better. I mean, Iro is probably going to be able to expand on that more, but we're educating them on to be cognizant, to be respectful, to be thoughtful of their colleagues. As Emanuela said before, if you go to med school, they will tell you, well, are you sure you want to be a surgeon? I mean, you're a woman. And from personal experience, I was mentoring in a really big mentoring program, and we had a lot of MDs, residents, and 2021. Two of the professor actually said to the female residents, you don't want to do neurosurgery. This is too tough. Just go do family medicine or something easy. So these are, yeah, these are the things that we need to educate, not just males, but females. We need to educate the world, period, that we're no different, that we can do everything. And I know I sound like I'm chasing a unicorn, but I believe it starts happening.
So Ellen, if I could add to that, I totally agree. It's not only empowering the young girls, but also trying to change like attitudes or how young boys perceive women and women in science. So I have an 8-year-old, and when they ask me, why do you work so long hours? Why do you do this and that? I say that it's because I want to be a good role model for my son and show to him with this way that I can do everything. So it's really important what you said.
I'm just waiting for anybody else who wants to weigh in before I move away from the topic, because I can see it's a loaded topic and it means a lot to everybody. All right, well, there's a very beautiful discussion going on the chat. People are sharing their own experiences. So before I move on, all I want to say is people, no matter who they are, they're going to try and put you down. They're going to try and tell you, oh, you're not good enough to be a doctor, or you're a woman, you can't be a surgeon, or it might not be always about if you're male or female. It might be because somebody just wants to feel better about themselves. The only thing I have to say is just don't believe anybody. Just, get back up. You're going to fail. You're going to fall flat face in your head, but get back up. And if you have a dream and you work hard enough, everything is possible. So another question is actually for Emanuela. I'm sorry, I'm looking for the actual question. Can somebody, you mentioned a multidisciplinary program that you attended. In your opinion, is it feasible to access an MD career even if your first degree is in other sciences like physics or math? Yes, and I think we should focus on the Greek side, because I know that in the US things are a little different.
Exactly. So, in fact, we need to say this though, like not everywhere in the world, kids, because you're a kid when you're 17 and 18, are expected to know if they want to become physicians or if they want to become mathematicians. And in fact, yes, we need to say this, that, for example, in the United States, you don't go to do medicine first thing after high school, right? You do pre-med, which in many cases is biology, maths, physics, even arts, and totally different discipline, like totally different degrees. So, and then you essentially apply to med school, where you really understand what you're doing and if this is really what you want to pursue. Now, going to Greece, indeed, most of the times, the majority of people just do one, like myself and many people in this panel, just do one graduate undergrad degree, and then they move on to master's and PhD. But I want to tell you that, in fact, in my med school, in my class, I had quite a lot of, like, I can think of at least 6-7 people who med school was for them their second or even third degree. After physics and after physical therapy and after different initial degrees. And I want to tell you, indeed, that these people, all of them, were very determined, really were very mature on what they really wanted to pursue. And they did great. And actually now they have really amazing careers already started in Greece and abroad. So, like I said, nothing is dead end. There are many ways to reach where you want to reach. I think it's actually, by seeing these people, I think it's a more mature decision, even if you do it at a later stage. And always your previous degree can help combine with medicine. I think these people had higher chances to become physician scientists because you always also love the science you've already done. And I would definitely advise you to go ahead and try to apply to med schools and take the exams, katatacterias in Greece, or even abroad. So.
It sounds like a general consensus. We're trying to tell all of the people that they're listening to us for the past 3 days, just do it anyway. I know we sound like a Nike commercial, but I think that's what we're trying to say. Just apply, just try. As I said on Friday, not trying is actually worse than not winning or not getting in or failing, because then you'll never know. So I have a question from me. but it came into my mind after one of the comments that popped up in the Q&A. Somebody said that we're all great role models and they're thanking us for this. Speaking of role models, I wanna ask, and I know how things work in academia or even academic research, but I wanted to ask Katerina specifically. She's in a private industry in Greece, and I was wondering if you guys do internships or if you have some sort of mentoring program where you can become role models for younger university students, or and then that question always extends to everybody else.
Thank you, Helen. Yes, I can answer, of course. Just sharing my experience also as well, not only from the current from my current employer, but also I was in Greece for the previous employer as well, from the last let's say 5 companies. I would just like to share with you that there are a lot of internships, yes, that you can run. Actually, myself and the team generally are trying to include internships and people and give opportunities to people in order to come and work with us and link, let's say, their academic career as well with the industry, which I consider essential. As when I was also in the academic part, I was also thinking of going on with master, PhD and all these. I was also having I had also been selected to go with a PhD, and I didn't have the opportunity to balance those things together. So yes, we are trying to push this. We have a lot of internships. We give opportunities to people and to anyone that wants to go for it and see how it works, how people can link the, let's say, their skills and what they want to do with the internship part. And generally, we have created specifically for Greek women and community in tech and STEM also projects and activities in order to ensure that all these women are included. We can coach them and, of course, give them opportunities to see how the real work in industry works. And personally, I try to have a balance in my team, though I still have more women than men. This is not the sexist part, is the fact that we give balanced opportunities to anyone in order to actually see what they want, how they should be in the, let's say, 5 years. We try to advise them that they should not give up academic if they want to go and have research in order to go for the internship part, but they can combine them, and research is also in the internship part, and combine both. I think it's actually the way that we were, let's say, that we grew up, and I think that the new generation have more skills, will be more aware on this, as a lot of opportunities are taking part. So I think this will give also the chance to go further on it.
Thank you, Katerina.
And just to add, sorry for Helen, just to add also that this is also very, very valuable for the industry as well and for the companies, because a lot of skills are coming from young employees, and the employees can also see what they want to do actually, but they also offer, let's say, valuable insights in order to go further and innovate, which is what makes the world change actually.
I couldn't agree with you more. Okay, we're getting, so the next question is a little more esoteric, but at the end of the day, that's what we're doing. We're holding a session for advice in career and, in industry and academia. So the next attendee is asking, I think I would like to become an astrophysicist. So I think, Martha, that's up your alley, or at least the physicist part. But I can't study or work abroad. Is there anything that I can do in Greece?
Right, I'm not sure that's my field exactly, but I do have a couple of friends who are astrophysicists in Greece. So,
please tell me they're also women.
They're not women, no, I'm sorry. I think they're both, they graduated from physics department in Athens, and then went on to specialization in astrophysics through a PhD. So that's the route that I am aware of. I also, now, if you really want to work as an astrophysicist in Greece, I'm not sure what to advise on that or what sort of positions exist. Maybe someone else is more familiar with this. You know,
So maybe,
can you help?
Yeah. First of all, it's like another stereotype. Can I do that in Greece? I think we are in the 2021. You can do everything from Greece. There are a lot of opportunities in Greece. And we're all now in different parts of the world and we're working together. So astrophysics, it's Martha is correct, it's from the physics department. I actually have women that are astrophysicists and they're now doing their researchers in universities, in Aristotle University or in the University of Patras in Athens. And so they're actually really into academia. The work that is in Greece, but I also have friends, again, women that work in space. I don't know if they've studied astrophysics and then they went to like space and robotics, and they're working for companies that have to do with this field. So there are a lot of opportunities. Astrophysics is a wonderful field, and there is also a lot of things to do also in Greece.
Thank you, Iro. So Marilu actually just posted on the chat a very helpful link. Marilu, you can explain what that is.
Yeah, there's so many things to do in Greece with astrophysics. Crete would be one of the places to go. I'm just going to share these links to the general chat. I just shared it with. Can anyone see them? No, it's just for the hosts and panelists. But the best thing that's, you're saying you can't go abroad, you can't go to work there, or, any of that, that's fine. But you can still get funding from abroad to do your project in Greece. So ESA is one of the really fascinating, it's the European Space Agency, and they also offer funding for Greek nationals as well as other European nationals. And yeah, just have a look at the links and browse, and you will see there's a lot of things you can do in different places, different locations in Greece. Now, if you don't want to move for your current location, wherever that may be, it's definitely worth seeing what you can do if you need to commute. So yeah, enjoy browsing.
Thank you. So as you can see, no question is a small question. Please put your questions on the Q&A. We'll do the best we can. And as I can see from the chat, even if we don't have the answer, there is quite a few people that might actually have the answer. So keep reading the chat. So I'm going to move on from astrophysics because it's a pretty scary subject to me, at least. And I would like to ask a question. I believe it's for Mariana. Yes. So you touched upon the fact that you were in a male-dominated environment. I guess most of us have this experience. Did you ever felt that being a woman, you might had less opportunities than your male colleagues? And of course, it's not just for you, but everybody.
So that's a good question. So I think when I was studying, I assumed I'm not as good sometimes, and this assumption made me not work so hard and not be so motivated, to put it in another way, because I would see them. There's also like the stereotype of a computer engineer being a guy. This is like, although in my department, we were, I would say like 60 to 40%. So it wasn't very imbalanced, but still I thought I'm not going to be good at that. It's not something I will be good at. I had this assumption. This really changed when I found what I liked. And then I really said, no, actually, this was so stupid. So I think like in the first years of my studies, I was really detached for two reasons. The first, I didn't like the topic. I think this was the most important one. So I couldn't see myself working as a programmer because I didn't see the application of that. You know, I thought, okay, I mean, it's interesting. Like, I like the fundamentals of computer science. I like the math behind it, but I never thought, you know, it's a job for me. But when I found an application of that I was really, you know, intrigued, then it really changed. Now, as far as opportunities are concerned, it's the same thing that everyone has said. I don't think I was ever discriminated because of being a female, but I just would not apply to things, you know. Just like when, for example, I told you about the scholarship, my first, you know, I thought, okay, I will apply, but there's no way I will get it. And then my professor told me, no, come on, I will help you with the application. You should go for it. And other opportunities as well, like when I applied for the postdoc, I thought, okay, I will go to meet them, but I'm sure I'm not going to get it. I had this mentality. And I also see it a lot now when I'm mentoring students, and especially students that have worked with me, you know, for their thesis, and I know how good they are. Like 9 out of 10 girls, they would tell you, should I do an internship maybe before I apply for a PhD to learn more, to have more skills? They try to find a way to get more skills because, as Theano said, when they see like, you know, this position, they ask for this and that and that and that and that. They say, oh, I know 9 out of 10 things and I'm not going to apply. And then you have a male candidate, they know 3 out of 10 things and they apply, right? And if you see how they write cover letters, how male candidates write, even students that I had personally, you know, and I help them like with like job opportunities, it's so different. You always have to intervene to the girls and say, no, actually, you're really not doing justice to yourself here. You have to really talk about this and that and that. And then for the males, it's always more pumped than how they actually were. So I think I never personally felt discriminated, especially not where I work now. And also, again, I don't want to sound like I'm advertising my workplace, but you have to realize we do there's a lot of effort at a company level not to discriminate. There are a lot of opportunities for diversity. You know, we talk a lot about these things. We spend time on these things. And that's another thing. Like, if you want to find good female candidates, you as an institution have to actively search for female candidates because they won't apply. You have to reach out to these people yourself, at least now. Maybe in 10 years, it will be different. But right now, as you guys did for the awards, you have to convince them to apply for the positions. They are not going to do it. You're going to get 9 CVs from males, completely irrelevant backgrounds. They're still going to apply for that job. And you would need to convince to reach out through networks and so on. You would need to do your job. And this is really something that all companies are now taking very seriously, that they already account for this discrepancy.
Thank you, Mariana. So what I was thinking while you were talking is we kept talking before about how we should educate the younger generation, educate men, but I think it's very important we also educate us, because for some reason we don't self-promote ourselves. We suffer by quite a bit of imposter syndrome. We think we make all those assumptions that, of course, they probably have to do with the way we're brought up, as Katarina said, but I think reconfiguring the way we're thinking is a massive adjustment we need to make. So we have a very interesting question, and I don't know the answer to that, so I'll just leave it up to whoever wants to take it. One of our attendees is asking how you could potentially survive a toxic environment at work. And also, if you rejected a job offer, but then you regretted it, what's the best strategy to go back and regain it?
So for me, and of course, it's just personal opinion, I would say any work that's not making you happy, just leave. Again, it's absolutely not worth your mental state. The reason why I left from the States is because I was having a terrible time in the lab, like worst experience of my life. And then I thought, why on earth am I accepting this? I can just go and get another job. And I did. For the second part, I would say, if you don't ask, you'll never find out. So definitely ask, maybe be honest and say, maybe I was too hasty rejecting the position. Is it at all possible that I could accept it now? Is it still available? For me, honesty has always been the best way to approach things.
Can I just add something here? It really depends on the level of toxicity, what's going on, and all of that. So in some countries, for example, the law is your friend. And if you think that someone is discriminating against you at work, and this could be a constructive dismissal, so basically they're making you feel bad so that you will either leave your job or they'll make firing you easier, then you can bring it up to HR. Now, if you're in a country that there are unions, then you can also bring it up to a union. But it really depends on why the environment is toxic and who is making that. Is it a supervisor? Is it someone who's a colleague? What are they doing exactly? But don't just sit, just go and speak either to a manager if that's not the person who's causing that environment, or go and speak to HR. Some companies may even have organizational psychologists, but again, without knowing which industry this is in,
I think in this case, it was a PI, so a principal investigator, discriminating between men and women, as far as I understand, based on the comments. So it's a manager.
Yeah, it would be good to know as well the country, right? Because depending on where you are, you can do different things. So if that was in the UK, you can really do many things. You can even get that person to be punished for doing that. But I would agree with no, if you find a place is toxic for you, why expose yourself to that? Just get your skills, make sure you just leave in good terms. There's no need to be mean to anyone. Make sure you just say thank you very much for what you've given me, although inside you just want to burn everyone. And then just go to the next step. Yeah, anyone want to add on that? And then I'm happy to take on the second part.
Yes, I have something actually, if that's all right. So I think, yeah, like how Marilou and Thanos, how Marilou said, it really depends on who is creating the toxicity in the work environment, because it's different if it's the boss, if it's the supervisor, if it's the person who offers the employment to you, and it's different if it's a colleague, an equal, or a person in a different position. And I realize that sometimes, and maybe it's too personal, but the toxicity also can come from low self-esteem. At least it has happened to me, feeling a little bit that maybe I'm not adequate, and that gives space to other people to be toxic with you. And what I realized in the past years is that sometimes it can be as simple as putting boundaries. And I'm not talking about really sick situations, obviously, where you really need like to go to HR or to even leave the job, which is good when you have alternatives, but sometimes it's not as simple to leave a job. I feel like putting boundaries to colleagues and make them understand that there is your space and there is their space, and some things will be reported and will be mentioned. I found out that this stops a lot and actually improves the environment, and you can end up also being friends with these people in the end. So that's some piece of advice. And again, if the toxicity is in not like sick and extraordinary ways, just competition or something like this.
Thank you very much, Emanuela, and thank you very much, everybody. I think the biggest takeaway is be honest, and literally, if you don't like it, you can do better. And maybe they can do better as well, because if you're not happy, you're not as productive. So we're, I can't believe I'm saying that after 3 days, after 3 amazing days, our Symposium the sessions are over, the educational sessions are over. We have our awards session coming up in about 10 minutes. Please, I will see you all there. But before we pull the plug on this session, I would like to just do a quick roundtable to give the opportunity to the speakers and the panelists, not only to say their goodbyes, but also if they want to share a little piece of advice with all of us. What would you like to know when you were at the very early stages of your career, or what you did, somebody you'd wish that they said that to you? I'll start with the way I see you in my screen. Iro, you're over on my left.
So I would say, like, don't ever forget that the sky is the limit. So you can never imagine where you will end up, as long as you are positive, you're hardworking, everything is possible. And the other thing is that it's really important to have around you people that actually support you and believe in you. It's really important. If I didn't have my husband, I would not be able to do half of the things that I have done this past years. So it's really important to have a good support group around you, and do not give up on your dreams.
Thank you. I have Fenia on my right.
What I would say, I wish I knew that at the time that there were more than one ways to get to where you want to go. I think I wasted a lot of energy stressing about the fact that if I don't get an industry position straight after my first postdoc or after my PhD, that then I won't be able to get in. And that was so incorrect, because everyone in my department, for example, has transitioned from academia. Yeah, that'd be it.
A little note to that, I actually remember sitting with Fenia at a coffee shop years ago, and she was very, very concerned about, if I don't do this, if I don't do that. We all go through that, and support is very important. I see Martha over this way.
Well, I agree with what Iro and both Fenia said. They're all exceptional advice. I would say that you should always have a plan A and a plan B and C and D, and how many plans it takes, so that you feel as safe as possible. And the other thing is always do a background check. Either if it's for your project or your research or your supervisor or the group that you're going to join, always do your research.
Thank you, Martha. That's actually a great advice that you don't hear very well, and you don't hear very often, and people do tend to forget.
To also not forget that when you're interviewing for a position, you're also interviewing them. So it kind of goes well with the background. If something's a red flag, and if you think this might be a problem, then you're also allowed to say, no, thanks.
Absolutely, yes. And that's the thing that I wish I knew earlier back. It's a two-way interview.
Of course. The next person I see is Mariana.
So it's really, when you're not the first, other people say the stuff that you thought they said first, right? And they were really exceptional advice, what was already said. So I have to go to my probably third advice on the list, which is probably if you're not going to apply for that scholarship, grant, position, whatever, someone else will. If you have second thoughts, other people don't have second thoughts. And very often is the case that you're actually better than these people that don't have second thoughts, and they end up getting these positions. So go ahead and apply. The worst thing that can happen is that you don't get it, and you learn. Always ask for feedback. If you're rejected on something, it could be, you interviewed for a position, you didn't get the job. It's totally fine to reach back and say, would you be willing to give me some constructive feedback? What do you think I could, optimize in my CV, or what skills am I missing? Don't be afraid, just ask them. Most of the times people will politely give you honest feedback, and you will learn so much from that. don't get disappointed if you're facing failures, because I think that someone told me this very recently, and it's so true. You see successful people and you think, wow, they have everything sorted out and, they know everything and so on. You don't see how many times they failed, how many times, I don't know, Nature Communications paper might have been a 5th submission on all other nature journals, right? Or whatever, like grant that they got, maybe they had it rejected 3 times. The only difference is that they do not stop trying. So grit and perseverance, I think, is very important. Don't stop trying.
Thank you, Mariana. Katerina?
Helen, just to add also on Mariana, because I had the same thought that there is no success or failure. The thing is that actually success is there and makes you going forward, but failures are here in order to give you the opportunity to learn how to go and achieve your successes. So just make your dream, do it, believe it, and everything will be here against all odds.
And as I said before, the Nike comment, just do it, just go for it. Well, there is a reason why it was so successful for them, right? Because it's very true. Emanuela, I think it's your turn.
Yes, sure. I agree with everything. I think the most important things have been very well said. One thing I would like to add is the importance of the support system. So I would say in the times that you're trying to think what you want to achieve, keep the people close to you, keep those who feel that they give you useful advice, they intend very well. And the second thing is there are many ways to reach where you want to reach. It doesn't matter where you start from. There will be success and there will be failure, which like it was said, it's not really failure, it's useful feedback. If one person did what you want to achieve, it's doable. If you know one person who is where you want to reach, a woman, in my case, a physician scientist who has her family, then you can do it too. It might take a while, it will have up and down, no path is straight. There's always turns and ups and downs, but if one person did it, you can do it.
Thank you. And last but not least, Marilu.
Yeah, I just have one thing. Be kind to yourself. We tend to forget that. It's okay if you don't do something, or if you're not at the right time making a decision, so what? You'll do something else. But just be kind to yourself. You're the only thing you have.
I couldn't agree more. So we're done. I will leave you with a quote, because I love quotes. It's from Walter Elliott. Success is no accident. It is hard work, perseverance, learning, studying, sacrifice, and most of all, love for what you're doing and learning. Perseverance is not a long race. It is many short races, one after the other. So just don't give up and follow your dreams. And we will see you all at the award session in the link that has been provided to you. It's the 4th link, the 4th and final link. I can't wait to see you all. We've had incredible applications from so many people. It took a little bit of effort and pushing to get them to apply, as we said, but they did it anyway. So now we get to celebrate their accomplishments. Thank you very much. It's been an honor to have you all.
Thank you, everyone.
Thank you.
Bye.
Bye.